streaming.
On an Xbox. That's Brad. Oh,
I see it here. Is it unlisted? I don't
on
think
an
so.
Xbox. That's Brad. Oh,
I see it here. Oops.
fine. Just set on them.
There we go. Now it's working, I think.
Let's go.
Hopefully I didn't just shut it down. Oh, okay, it's working. There we go. Now I'm going to share it in the server just to get the viewership
I,
up. Everyone, let me see what my last one was. Red mode. Tropical weather. Tropical weather ping. Red mode, Filipo closing in. There we go. It's all public, so that should... Alright. Should get a couple viewers soon. We got one right now.
go.
Make sure everything's running smoothly. Nice. Alright, so current look at Filipo, officially 70 miles an hour, or 65 miles an hour, 10 minutes, which is around 75 miles an hour, 1 minute. Shoot, I need to update the top bar real quick. Alright,
Yeah.
Cyclone Filipo is closing in on the Madagascar coastline with 80 mile an hour sustained winds and a central pressure of, I think it was 985 millibars.
Somewhere around there.
Yep. Alright, there we go. Nice, now it's live. Alright, so Cyclone Filipo is, of course, approaching the coastline. Around where its center is, okay, pulling up roughly around 30 to maybe 50 miles away from the coastline. That is around, I'm going to change the setting just so I'm on kilometers, like kilometers per hour, kilometer distance. Alright, and so it's around 50 to 90 kilometers away from the coastline of Mozambique. I gotta wait, did I say? Oh shoot, I said Madagascar coastline. Let me change that. Mozambique coastline. So yeah, it's continuing to barrel down towards the coastline. This system has quickly intensified. It's around 110 kilometers per hour. That is, let me figure out how much we have it as. 80 miles an hour, 2 miles per hour. Okay, roughly 130 kilometers per hour winds. I'm gonna add that in on here. 80 miles an hour. That is 130 kilometers per hour. So it could definitely strengthen some as it nears the coastline. How much time do you think it has until landfall?
Till landfall?
Mm-hmm.
Not very long, I would imagine. Maybe a few. At this point, it looks like maybe a few hours, although it hasn't been moving particularly quick. Let me take a look at this point.
Wants it to make
It's been
landfall
moving
within
very
like the next 3
slow.
hours. Yeah.
It's been doing two things. It's been moving very slow, and it's also not moving directly towards the coastline, which is actually a net negative for potentially seeing some more significant impacts than expected for the coastline,
Mm-hmm.
as the system moving slower, not only does it increase the rainfall threat, but it also allows the system more time over warmer water to strengthen, considering that it's already developed a well-developed pinhole core and is intensifying very quickly. So the amount of time over the water at this point, the more time, the worse for
Yeah.
land areas. Um,
It's there's nothing really weakening it right now. There's no shear
yeah,
really impacting it. There's no eye wall
and
replacement cycle. It's just the more
let me take a
time,
look
the
at the
more
PIA really
strength.
quick. I'm going to go pull up a few things. OHC, sea surface temperatures, a bunch of
Yep.
things.
In the
We
last
should be able to
six
get this.
hours, it was moving 10.5 kilometers per hour, or around 6.5 miles an hour.
Yeah,
So very slowly. And if I put that in here, if it's around 50 to 90 kilometers away from the coastline, that would be around
and look.
5 to 9 hours up until landfall.
Tropical cyclone heat potential, southern Indian Ocean,
Can you
around
send that
where
in
it
the
is
group
right
chat?
now.
And then I'll pull it up on here. Or it's Tapaya,
Okay.
right?
Yeah. All you have to do is it should be right there as soon as you pull up the PIA. All you got to do is just change it to tropical cyclone heat potential and then southern Indian Ocean. You can see how much there is.
Where to go? Right here? Okay.
Um,
Tropical cyclone heat potential, and then Southwest Indian Ocean.
yeah, and you can see where it is on the
Is
far left
that
of the
the
image.
part that it sucked up out of the area? Or no, no,
It seems
that's
like
March
it.
1st.
Yeah,
So
you
this
can
is
see
before the cyclone.
there's still some decent OHC units though where it is. But it is one of those things where if it did stall, it would theoretically up well. Although, like the intensity of it at this point really isn't the main issue. The issue is the amount of rainfall for these areas.
Yeah,
Intensity is pretty much irrelevant.
yep,
So even though it's technically intensifying as it heads towards the coastline, the wind speed should be the least concern. The most concerning thing right now is the amount of rainfall, the amount of storm surge, and just general water impacts over the area.
yeah.
As that's usually what does the damage for
If you can
these
compare
regions.
this oceanic heat content to something in the Atlantic during like peak season, where would you say you'd put it?
Um, I would say so. I
It's
think
around 50-ish.
50-ish. I remember. I think let's say Dorian, for example, is a good example of another
Like, let's
storm
say
moving
this was
slowly. It's a
peak
little less than
season,
that.
then like how
If it
far
were
up
peak
would it need to be
season,
if this was peak
this is
season, for
similar to a
example?
system probably just outside of the Caribbean most times
Yeah.
during peak season. Um, Usually when it's in the Caribbean, there's over twice this amount of ocean heat potential.
Hmm.
Um, but it's decent. I would say it's not the best, but it's not the East Pack either, where if a storm stalls for 6 hours, then it's gonna just completely upwell all of the water.
Yeah.
It's not like super shallow, but it's not super deep either.
Hmm.
Generally, I'd say decent.
All right. So, do you think that the system could reach Category 2 status?
Highly no, no,
Yeah. All right.
straight up no. Um, I would say its ceiling intensity right now is probably about 85 miles an hour.
Yeah. Maybe 90 as it gets closer
No,
at
and
landfall.
not even
Okay.
90. I think 85 is just a straight up ceiling.
All right. So, current wind forecast. This is just a general idea of what it looks like. As let me pull up. Probably the icon shows it a little bit stronger. Okay. Can it? All right. So around Vilanculas, around 60 kilometers per hour. Definitely a lot higher. These models underdo it a lot. Yeah, around the center, like this is just. Oh, hold on. Let me pull up wind gusts. This would do a better idea. Yeah,
Okay.
around definitely over 100 kilometers per hour in terms of wind gust for much of the coastline over here, near the center of it at least.
Something else
The
to remember too.
mhm.
Um, Anywhere that is south of the projected path is going to be directly in the path of the storm surge. Anywhere that is
Yes.
north of the path is going to have offshore flow, and therefore you're not at a risk of storm surge.
If this center made landfall on the southernmost area of the cone, then all the storm surge would be funneling in towards Vilanculas. That's why you see
Yeah.
all the wind over there. And if it went to the northern part of it, let me see if the GFS shows it. Oh, No, that has it going down the center. But if it was over here, for example, then it would all be funneling the storm surge up more north, and then Villanucolas wouldn't get all that much storm surge compared to if it was right next to it.
Yeah,
Don't know how populated the areas are. That seems like a decently sized city because it's featured on here.
yeah, it does seem like a pretty large city in general. Let me take a look um, of where that city is, right quick. Um, Vilanculo, you mean?
I don't know.
What?
It says it's around 24,000.
Yeah, that's what I just thought too.
Yep, all right. So yeah, it's a decently sized city. I guess the other areas are more rural or just not much cities at all in that area. So guess the more north it heads, the better because there are larger cities up
Um,
north, but if it does hit there, it wouldn't be as and also like the quicker it makes landfall, the better as well.
it seems like generally looking at it right now, the structure of the storm is definitely evolving in a way that would usually favor rapid intensification. We have dual VHTs, one VHT on the southeast side and another
Can you
burst on the
explain what
northwest
that
side.
is to the stream?
Vortical hot towers. So, vortical hot towers are basically the mechanism that, or not the mechanism, but it's basically the formative parts of an eye wall.
It's the
And
stuff right here,
taking a look, you should see it because it should be the taller tops.
like this stuff right here,
Yeah, go to the newest one, and you should be able to see them very well. Yeah.
like
So
one
look
right
on the
here,
northwest side of the center, and you should be able to see a really, yeah,
right over
you can
here.
see it. Where those pinks are, yeah, those are vortical hot towers.
Yep.
So, um, those are basically the latent. Those cause the latent heat release that actually helps to sustain the warm core. That is the fundamental mechanism behind the warm core strengthening in a tropical cyclone once it
Yeah.
gets to this intensity. So
We can expect
generally,
more as it's like they form and go, right?
yeah, yeah. Generally, they'll rotate around the center. You usually, what you'll see is you'll see two of them on each side, and then they symmetrize into an eye.
Kind of
But
like
in
this
this
frame
case,
earlier,
yeah, that's a good explanation of what they do.
and then it adds more convection over the center. And as this wanes, then there should be more. There's also a good band that form to the eastern side.
Let me take a look at this. Good feeder ranger, Sam.
Yep, that formed recently. It formed at around
Yeah,
15Z. Started developing better.
yeah. Thankfully, that's offshore. Generally,
Now it's weakening somewhat ish. It is expanding though.
I'm assuming that feeder band signals. Yeah, that signals that there's probably um getting closer to like or not convective minimum, but D-min.
Yeah.
Or wait, isn't Dmax actually morning? I think Dmax is in the morning typically.
Aren't there like two peaks of Dmax? I don't know.
No, you have. I know that in the morning it's the most convection, and then typically once you get through the day towards the evening, it's the least.
All
So
right.
for tropical cyclones, just remember it's backwards. The most convective activity occurs in the early morning hours, and then the least convective activity occurs before sunset.
Mhm.
So in tropical cyclones, it's always the opposite of what you'd expect, like on land with usual thunderstorms.
Yeah. All right.
I'm
So
gonna.
waves look like they're
I'll be back in a
around
bit. I'm gonna go
9 or
talk to my
7
mom.
meters.
She's at
Okay.
home.
All right. Waves look like they're around 7 meters near the coastline. Definitely, the more time it has, the more time that the waves can increase. Definitely not good. Most of the areas here in terms of rip currents. And then also the storm's going to go right back out to sea. Get meters up to around almost 10 meters up. Now let's talk about precipitation. This is going to be an interesting topic because it is going to be like due to the brown ocean effect, which is basically when tropical systems sustain themselves over land sometimes, especially in Mozambique. It is going to be continuously producing large amounts of rain wherever it goes in its path. Of course, near the landfall site is where it's going to be the highest, around 7 inches, 8 inches, which is over 200 millimeters. But like you could get over a foot of rain in some isolated areas. But of course, definitely around this whole area, definitely spots of over 3 inches, nearly 100 millimeters or more in the path of wherever the center goes. Then offshore, thankfully, then it's out of mind, out of sight, out of mind, so that's good. But of course, anywhere in this yellow zone or even the green zone can get some localized flash flooding or gradual flooding as well. So yeah, let's take a look at the wind shear that the storm is going to be facing, if any at all. Like look at model data. All right, here's one of the latest microwave passes of it, so you can see how it has a developed eye somewhat there, which does show it does have a nice looking core to it, and when it finally develops that, it can develop more rapidly as well. If this was given another 24 hours over water, this could definitely be a major cyclone. But since it's not,
I'm back.
since it's going to be making landfall soon, it doesn't have much time to
Okay.
organize. Hello. Just
Yeah.
showing
So,
microwave imagery. This was
um,
as of 10Z, so a while ago.
taking a look. I want to see what it's.
Alright, let me see if I can pull up model data on it.
This really would strengthen quite a lot if it had more time over water.
Yeah.
It's got a very nice polar outflow channel, which is if you ever want to see the outflow, make sure to use water vapor, and you can see.
hmm Here's what it
Um,
looks like right now in terms of wind shear. Wind shear has been climbing recently. Or I think so. No, hold on. Never mind, wrong thing. That was intensity. Wind shear has been actually lowering somewhat. Sea surface temperatures lowering a bit, but they're still very favorable for development. Looks like it's a little bit dry. But here, I'll pull up water vapor imagery. Oops. Filipo, there we go. Alright. Water vapor. There we go. Very moist, though, around the center right here. Looks like it's a little bit
yeah,
dry over land in this area.
yeah. So it seems like some of the daytime mixing that has been occurring earlier is now wrapping around the north side of the circulation, which might be a reason why, generally, other than at the center, the system's been somewhat convectively anemic.
Explain what that is.
Convect. When I say convectively anemic, that means there isn't really a lot of convection, a lot of deep, robust convection. Like if you were thinking in the Westpac, you're filled out. You have convection everywhere surrounding the center, and it's
Yeah.
a very symmetrical look. Here, you have multiple areas where you can see just no convection at all. Multiple
Like
gaps in
right
the
over
convection.
here.
Um,
Right in over here. So yeah.
where you generally just see like stable air cloud streets instead of billowing thunderstorms. So
Yeah.
in those areas, that's telling you, hey, there's some pretty dry air in this environment. There's not a lot of storms don't want to form there.
Yep.
Generally, the fact that it is a little bit like that because it's been close to land is good. It means that generally rainfall isn't going to be as widespread just because it isn't as filled out of a
hmm
system.
I do
So,
believe rainfall will be kind of high due to the brown ocean effect. Just it's sustaining
oh
itself
yeah.
over lands.
In either case, the rainfall is going to be a problem. But if this was a stronger TC already, it would have been even worse.
Yeah. Also,
Um,
it all depends on how close it gets over to land. Okay, here's a good model right here. The Arome. It's a model for this region. All right, so here's roughly where it is right now. Let me see if I can pull up a different thing for rain and thunder. Yeah, so this is what it looked like roughly right now in terms of rainfall rates. The western side, northern side as well, has the most intense rainfall rates. Then there's the band to the east. And there it moves, starts circling around it. Could get a decent eye wall out of it in terms of heavy rainfall rates.
Its
And
eyewall
then,
should have heavy rainfall rates all the way around already, looking at it.
yeah, yeah.
Um, Given that it is a small core, something that is a bit undervalued is that this is a small core. It's not a system where you have this, 50 mile wide eye wall that you would usually see. Or not that you would usually see, but that you would see in
Hmm.
some crazy landfalling scenarios. This is not one of those scenarios where you have a huge eye wall that's going to take a very long time to slowly wind down over land. These small vortices, these small systems like this or like any other pinhole-eyed system, they're gonna dissipate really fast. They're not gonna waste time, winding down. So the wind threat's not gonna be a problem.
It's like the
Rainfall, no
whole
matter what.
center of it is roughly 80 miles. Like
Yes,
the
but
whole center part, and not
I'm
even the
saying
core of it.
I'm saying the radius of max winds is
Yeah,
going to
yeah.
weaken really fast. So
It's a smaller system.
yeah,
Thankfully, it
which is
should be a
good.
tropical depression somewhat soon, with like within the next 24 hours. Also, the rainfall over the area where it makes landfall should be gone within the next 24 hours as
I
it
do
moves away.
suspect, since it is a little stronger, that it may last 24 hours over land
Yeah,
without being a tropical depression. It might still be a weak tropical storm by that point.
yeah.
Um, but it having a small center doesn't help its chances.
Hmm. This model shows the rainfall rates or like rainfall max over the next 12 hours.
Right.
It could definitely see some areas of over 8 inches of rain near the center of where it makes landfall. And in total, you can definitely see some spots of over a foot. May not be in this area, but maybe somewhere around here, just depending on how the system unfolds. I'm curious, is there a website that you could see like power outages? Mozambique
Let me take a look
outages.
at this.
No, it doesn't seem like it.
Tropical Cyclone 18. It looks like it's. I'm gonna take a look at TC 18 for a little bit.
Now let's take a look at
Take.
that system. As we've gotten multiple threats right now. We got 18S over here, which could become a strong tropical storm, maybe even a cyclone by the end of the 5 day period as it nears
I would be
Australia.
very surprised if this doesn't become a cyclone,
Hmm.
given its current look. Um. So, and I'll actually explain the reason I say that too. The system is going to be. It appears on most modeling that it's going to be coupled pretty nicely
I don't know if
after a
it's a
couple
cyclone
days.
right now in terms of because of the shear on it.
It's only, well, it looks like it's going to eventually break out of the monsoonal trough that's going to be, or not monsoonal trough, monsoonal belt of flow that's going to be
Yeah,
inhibiting it for the next few
just
days. It
needs more
should,
convection over the center. Right now, it's just wide open.
yeah. So it's got pretty strong shear for a few days, and then eventually it breaks out of that hindering flow and is able to intensify. Now, where it does that is the main key, and when it does that too.
Hmm.
Euro and Canadian seem to be further west. The GFS, obviously, with its convective feedback bias, is much further east. I would generally expect the system to be on the western side of the guidance,
Hmm.
given a history of these types of systems. But in any case, it looks like it'll have a favorable environment to get strong, just considering that everywhere it goes is generally
Now,
favorable.
the convection is around 130 kilometers or like 80 miles away from the center of it.
Yeah, which is expected. It's a very poorly stacked system.
Yeah, but eventually it should get more organized. We also got a system right near Australia, 93S or 93P. This system could impact the northern tip over here. I forgot the name of it. But or like the northern part of Queensland, I think. It is slowly trying to get better organized. Um, but right now it's just a mess of or a cluster of thunderstorms. And eventually that system should head towards or should pass the I think that's Queensland territory right here, and then it should be out of the area, head towards New Caledonia. Don't know what's going to happen then. Right. So next system right here is 92 p.m. All right. So this system right here, it could have been a brief tropical cyclone. It's hard to tell. Right over here, but now its circulation's dying out. It's near Vanuatu, so doesn't really seem like it. It's right over here. Earlier, like yesterday, it could have been one, even the day before.
Yeah.
But it was sheared a lot as well. Now let's take a look at the environments of all of these systems, especially like the forecast of them. If I pull up, uh, let's see, current active cyclones, see the conditions they're in. This is 18. Right here, let me pull up model data or wind hazards. What about this? No, okay. Model data right now in terms of wind shear. And so wind shear should gradually decrease as it gets closer and closer there. Sea surface temperatures will remain extremely favorable, and humidity may get even more moist, so very good for the system. Yeah, intensity, as you can see, most models do agree with the cyclone within the 5-day period, so that definitely can be anticipated as it nears Australia. The main thing is, where's it going to go? Like, we're not exactly sure. We do believe it's going to be, let's see, right around here within the 5-day period, possibly. There could be tropical storm winds on the coastline. This is the area where there could be tropical storm force winds within the next 5-day period. We don't know yet, though. It might go slower, might go quicker. And the center there is also the possibility that after the 5-day period, it just turns to the west and tries to curve away. But then again, there is the possibility it continues moving east and strikes Northern Territory or Western Australia.
Yep.
Right, let's see. 93
I'm gonna send you something, Chase.
All right. What's it about?
It's not actually about the tropical cyclones, but it's about what's happening over in severe weather. I'm not obviously focusing on tropical cyclones, but I'm just saying, like, send you some stuff.
All right. 93p, if I can get the model data. Alright, it doesn't want to load the model data for whatever reason. I guess it's just because it was recently designated an invest not too long ago. Low chance of formation within the next 24 hours. Same with the 92p. Alright, let's take a look at the overall perspective on the individual cyclones as well. Let me pull it up on tropics.
I'm going to put this in severe WX channel.
All right. I'm going to put this on stream. Okay, so this is what the cyclone looks like right now and where it's headed towards. We can take a look at the estimated wind shear right now, which it's not really favorable and it's not unfavorable. It's kind of in a decent environment. I don't really like. You can't really see the effects of shear. I don't think. Can you?
On this system,
Mm-hmm.
you have to look at the asymmetry and the convection to determine the shear direction.
It doesn't really seem like it, since on the model data it shows the shear flowing towards.
Well, I'm saying in the general convective pattern. So take a look at not just the core, but look at the rest of the system. Which side of it? So basically,
right over here on the southeastern side.
Yeah, you can see the southeast side is much stronger in terms of all the convection than the northwest side, which is telling you that, hey, there is likely shear out of that direction, out of the northwest direction, because of general asymmetry.
It looks like it's not really impacting the center though as much. Like
Yeah,
it's not disrupting its.
yeah. I agree. It doesn't look that disrupted to me. It looks pretty healthy.
All right. Let me see if there's an ASCAP pass or anything. No. Okay. Sea surface temperatures. This shows a good idea on what it's going through. Let me zoom out some just to show everyone the. Okay. Does it not? Okay. It doesn't show for whatever reason. Okay. Let me go back to this. So currently it's in around 29 to 30 degrees Celsius waters, which is very favorable. But eventually, when it reemerges back out to sea, the sea surface temperatures will be around 27 to 28 Celsius. It will be lower, but definitely could still be a tropical storm at that point. Then eventually, as it races off, it's going to merge with a front in turn post-tropical, and that's going to be out of the way. All right. This is a good idea of where it's headed towards. Most models agree exactly where it's going, as you can see here. It's not really. Basically, it's dead on the center. They don't merge over here or over there. They're basically all consistent on where they're going to be headed towards. But definitely, there could be a little bits of deviation on where it heads. Maybe over there, maybe further inland. The quicker it gets back out over water, the stronger it will be, and maybe it can intensify more. Do you agree that there is a possibility that it could become a cyclone when it exits?
Oh, well,
Do you believe there's a possibility it could become a cyclone when it exits out of the region?
a small possibility. I don't see anything telling me explicitly that it will or won't,
Hmm.
but
JTWC wants
um,
it as 70 miles an hour as a transitioning.
70 miles an hour as it's heading. Oh, wow.
Yep, because of the
Um,
jet interaction.
yeah, I actually. So this is highly dependent on how quickly it's able to recover after being on the landmass for so long.
Hmm.
If we see a GFSS solution, basically, if it comes off the landmass and it's only like a tropical depression, maybe weak tropical storm at most, then I could see it not getting stronger than 50, 60 miles an hour. But if we see a solution where it's still 50 plus miles an hour, even after landfall, then I could easily see a cyclone. So it
Yeah,
really, I would say it's more dependent on how it reemerges, how strong it is
uh,
once it
and
reemerges.
also how quickly it reemerges as well. Because, for
Yeah,
example, if it turns out on like if it goes more south quicker, and then reemerges there, that of course have more structure to it. But if it meanders over land more, like in the more northern or more western path, then its core would be shredded up more. But yeah, it should be at least a tropical depression as it reemerges. I don't exactly believe it'd be a remnant low.
yeah, I doubt it'd be a remnant low by that point.
It's
Doesn't.
already so strong, so and
Yeah,
it
it will
should be out
definitely.
over the water within the next I don't know how long that is, like 36 hours.
Yeah.
Yeah, GFS wants it to have a uh, still good core. Euro somewhat overdoes it, I believe. And then there's the front right along here that it merges with. So then it starts turning post-tropical, and then is out of the way. I don't know how long will this storm last as a post-tropical cyclone.
Honestly, I'm not sure. It just depends on when the circulation becomes unidentifiable. It could be a
Hmm.
day, it could be 4.
It shows it making it like for around a week before becoming a trough.
That'd be insane, but I mean, it could happen. It's just I
Yeah.
doubt it. In those situations where the system remains very well distinguished for a long time, you have to wonder. I'm gonna see if it's gonna rotate around a ridge and head back north or no. No, it doesn't look like it. Okay.
Hmm.
Um.
Euro wants a system over Australia besides that other storm. And take a look at that. Yeah, right over here within the 5 day period. The other storm leaves the area. Is that convective feedback right here? This storm?
Trying to see. That other storm,
Yeah, over or in the bay of that bay.
most likely, you would to determine it. If it's only the GFS that's showing that,
No, no,
then
no. That was
yeah,
the
probably.
euro.
Oh, that was the euro.
Yep, GFS shows it's.
There's a legitimate shot at it, I'd say.
CMC shows it's the Canadian.
Yeah, I think it's a legitimate
Icon
shot
shows
if
it as
all of the
well.
models are showing it.
Wow, yeah.
Yeah. So if you look at something over 5 days out and you see the GFS showing a Cat 4 plus, and then every other model is not even showing like a tropical storm or like maybe showing a weak tropical
Hmm.
storm, you have a prime convective
Yeah.
feedback sort of loop thing going on. If it's fine and all of the models are showing it, if all of the models are showing a significant system, not all of them have to be showing a Cat 5, but all of them are showing, maybe
A tropical storm or.
moderate tropical
Yeah.
storm, strong tropical storm, and the GFS's solution of a stronger storm isn't so much of an outlier. Then you start to look into the ensembles and see, okay, wait, we could really see something happen here.
Yeah.
So you just have to kind of know when to identify its issue.
Right now, that system looks to be around. Uh, like, there's one over here. That system's going to be moving away, so I don't think it's really going to develop before hitting uh, Queensland. I think that is, yeah, okay. And then the other one right over here uh, is going to be going over land shortly, but that land is, brown ocean affected. Could definitely try and develop and organize more overlands since it's right next to the water.
Yeah.
And then in the Gulf of Carpentaria, try and develop there. This is a very good spot for cyclone development there.
Yeah. Let me actually take a look at the oceanic conditions for systems in the Gulf of Carpentaria currently.
Mm-hmm.
Looks like we're well above average. As expected, SSTs are 30 to 31 degrees Celsius. Yeah,
You
I
guys
see
are
it.
looking at the wrong thing. They're two different things.
Alright, who just joined stream?
Hmm?
Oh, hey Casper, how's it going?
That's good. Just I'd point out that tropical cyclone heat potential is not the same thing as oceanic heat content. There's two ways to view them. I'm just going to take a look. I do have the site bookmarked, I'll pull it up.
Alright.
Okay.
So yeah, what are your thoughts on Filipo right now, Casper?
It's intensifying quickly. It's definitely taking advantage of its environment well, and the shape of the coastline nearby is definitely having a pretty good benefit.
Because it
Yeah,
bends
very nice
outward.
concave shoreline.
Yep. Instead of it hitting like right in this area, it's hitting on the outward bend.
Yeah. Generally, if you look at the coastline around it, considering it's like sort of already cyclonically curved, it can sometimes help the system intensify a little bit. You see
Yeah.
that a lot in the Bay of Campeche. You'll see systems spin up way more than models expected to, just because of the shape of the coastline.
Mm-hmm.
So you have to kind of consider that.
But storm surge, thankfully, since it bends outward, it shouldn't be as bad. Of course, any storm surge is bad in the area. Definitely should be prepared for that. It's interesting to see the band to the eastern side intensify, and then it somewhat weakens. It's
Yeah.
Is it D-men there? It is midnight there, I think, or it's almost midnight. 15 minutes.
Okay. I'll just say for the system, it's at a time where it would have it's heading towards its time where it would have the most convective activity.
Yeah. Okay.
Right. That's the oceanic heat content for the South Pacific. They're two different things. you will see that the oceanic heat content takes into account the depth of the sea, the the water basin. Tropical cyclone heat potential doesn't do that so much, focuses more on the actual temperature itself.
All right.
You can notice that there is different in the color there.
Okay.
Okay, I see it. Here, I'll bring this up on stream, if I can. There we go. So there's the ocean heat content. It's a lot lower in this.
Generally, because the Gulf Carpenter is quite shallow, so it
Which
won't
is
appear as prominent.
Yeah.
Yeah.
It definitely could see something forming in this area from that 93p.
Yeah, models do indicate a system there. I could see something there, yeah.
So what are your thoughts on 18S? This new...
Actually, I'm kind of interested in this other system. This looks now like...
I don't believe it's a tropical cyclone right now. I feel like it will be one, of course.
There does seem to be a degree of disorganization, so I could see how you would think that, yeah.
I'm waiting on the convection to be more over the center instead of being like 80 miles to the west.
Looking at it, its circulation is closed. It is very decoupled,
Yeah,
I do agree. Looking at, like, not visible, but I guess shortwave IR, I do see that the low-level circulation is at least closed, but it's not great.
Yeah.
So
we should see the easterly shape persist for the next few days, and then we should see the upper level environment get a little bit better, as you could probably tell by
like
the cone
wind
there.
shear should decrease.
yeah, it'll leave that belt of really strong flow over closer to the equator. That's just been really causing it issues.
Right. Do you think it could become a cyclone near Western Australia?
I think it absolutely is a potential too.
Yeah. And Casper, what do you think about it curving away? Like doing this?
I'm just going on the going on the walls real quick.
All right. Is some models do indicate it just going straight eastwards. Others show it going this direction, away from the coastline. Definitely the Western Australia should prepare for this, just in this area, just in case there is.
Wait, what?
This is what
I'm
the
gonna take a look at
ensembles
a
look like.
box.
Right.
I'm very confused by this GFS solution.
But yeah, the Filipo does seem very certain on where it's going. Of course, thankfully, it doesn't look like it's gonna meander anywhere else. It's just gonna go straight for the coastline, and then they're all very certain on where it's going. As you can see, all the ensembles have it going. Like they're very close to the center, meaning that they're confident on where it will be and what time.
Okay, I looked into what?
Looked into what?
So apparently for I didn't realize this, but for what system is this?
Which one? There's 18 that's heading
18.
for Australia. Yeah.
For some reason, I don't know. Something else you need to watch out for is GFS's intensity. Sometimes it goes a little crazy with the intensity, even when shear is clearly a hindering factor.
Yeah.
And it's showing the system after a few days becoming a monster Category 4, but I just I don't see that.
Yeah, I see it.
Like,
I mean, I see it on the run there.
38 millibar landfall or something. I just don't know.
Yeah.
So you have to watch out for that stuff too. Like sometimes the GFS's solutions, even if it doesn't look like a clear convective feedback one, sometimes it is, and you need to like just if it is with the other models, usually it's fine, but sometimes it can go on its own limb compared to the other models.
Euro
and a
has
lot
it
of
as
times
like a cyclone there.
Yeah, but you notice how much farther west it has it
Yeah.
and weaker. That's because of convect. That's also because of convective feedback. So that's the path it's taking anyway. A lot of it. It
Yeah.
can be very misleading.
Could definitely strike Australia eventually, though.
Yeah,
Hopefully
I
it
would.
just meanders away from the coastline like the black line over here. Just turns away and leaves the area. Of course, we can't just rely on that.
LZ, that's 18C. Okay.
There is a
Yeah.
pretty big spread across the models on where it will go, but there is a pretty. I guess there's a agreement between the models that we're probably going to get at least Category 1. The upper level conditions are bound to improve, and I would actually probably consider the GFS, while it would probably be overdoing it. Um, Storms are probably notorious for intensifying quickly within this area.
Yeah.
Yeah,
Among
they
one of
are.
the most favourable regions on the planet, to be honest, you got the absolute boiling waters, and obviously, if you look at the GFS one in a little bit more detail, I can kind of see where it's getting this rapid intensification from to a monstrous category 4. The upper level conditions, while an upper level trough does pass by to the south, we could probably get quite a nice um, jet interaction to just support a little bit
Yeah.
just before it
That's what
makes
I was
landfall.
concerned about too. When I did see that.
We'll just have to observe the models over the next few days because
New
at the
model
Yeah.
moment
run's coming out right now, so
we are still a bit away. I do reckon that when we do go a bit closer to landfall, maybe give it maybe 2 days or so, we'll get a better idea on how this trough interaction will go
yeah.
and however east it could go. Because what it looks like is at the moment it could be a case of further east it goes, probably more favourable it'll be. But then
hmm
again, it
Yeah.
will have less time over water as well the further it goes east, given that land does get to a lower latitude, and we're probably going to get a landfall sooner at that point, which wouldn't be too great. And we're probably going to get stronger storm at that point as well. So something to monitor.
Yes. All right. How long do you think it will take for Filippo to make landfall?
Let's take a look. Last time I checked, it was moving at around 6 knots. So we'll see.
Appears to be moving even slower than 6 knots in the past couple hours.
My measurement I had was okay. Here, let me check again. All right, where do you think the position is right now, Crazy? Right around here,
I
right, ish.
think if you're looking at it, so there's the VHT plume. I think the
Here,
position of it's
I'll play a
probably
loop of it.
directly at 21 south,
Like right over here ish. This is
just to the
21
west of
south.
36 degrees east.
West of
Probably
36 degrees east. Yeah, right around
just to
here.
the west. Yeah.
Yep. So it's definitely trended more south. Looks like.
And notice something too. Its path, like it is not moving very far west at all.
Yep.
It's moving almost due south in the latest frames, but it's definitely not moved as far west as I expected it to over the past few hours. Or really as any of the
Yeah, like
models expected it to.
here's the difference between the cone of uncertainty right now. Just barely out of it.
Yeah. It could just be a jog too.
Yeah.
But I'm watching
But
that
as well,
closely because
it is giving it more time over water as well.
yeah,
It does look like the forecast on how fast it's moving is it's staying in line with it, like right around here-ish.
you have to note too this southern trend. If this is a real southern trend and it's not just a jog, this may hold for a longer period of time and warrant the system more time, not only over water now, but more time over water later. So
Yeah, like if it's right over here and we keep that on the southern end of the cone right along here, it's going to be right next to the coastline. So more
yeah,
convection in this area could fire up and lead to it staying stronger for longer over land.
yep,
But hopefully we do get a more westward jog so then it could just be out of the area. or just just quickly weaken.
Taking a look at the new Euro solution, you see AIFS. That is, I don't know about that. The AI version of the Euro has it breaking from monsoon trough and then becoming tropical cyclone Angarek 2.0. That's not.
Which storm?
Um, for 18S, it literally has it breaking from the like monsoonal flow and then heading due
Oh yeah,
west
I
for
see
like
it.
4 days.
Yeah,
That is no.
I've seen the Euro or one of the ensembles showing it going to the directly to the west.
Yeah. Let me actually pull up Weather Nerds so I can see ensembles.
Hmm.
Um,
I'll pull that up as well.
because I like using the sends on it.
I go to
You see South Pack. Here we go. What I do is I just go to 240 and then just see everything immediately.
hmm
And then I go back to like 120 or something and see sort of start to decipher when
yeah.
everything's happening. So
So right here you can see how the models when it's shifting mostly to the west out of the way.
yeah, or at least this ensemble set does, which is
But there
good.
is a lot of lows around Australia there, northern Australia.
Yeah, this is pretty good. Here's what I will say: this is pretty good agreement. This is usually what it looks like when you have a broad monsoon trough that's forcing a lot of convection over a large area. Remember how I said like surface trough? I would say this is a monsoon trough. This is the one trough you do get in the tropics is
Yeah.
monsoon trough, and they span over a very long, large area and are generally very favorable for getting a lot of convection. Just generally,
I
and
did want to
sometimes
say though that real quick, the ensembles for Filippo do have it being mostly a cyclone when it reemerges back out to sea. Some of them say some of them nearly say Category 2.
wow,
Right over
that
here,
is
see the orange
yeah, that's
color.
quite the set. That is pretty
Let me
remarkable if I
zoom
were to say
in
so
more
myself.
on this, so you can right over here. Nearly all of the ensembles have it at least 60 knots.
Taking a look at SSTs, that's remarkable. You have so after with the jet interaction, you have an environment with 26 to 27 degree SSTs, and remarkably, not for just like a couple of, hours, more like a couple of maybe like a day or two down here.
Yeah,
I could definitely see where that cyclone forecast is coming into play. Usually, you don't see this very often.
definitely with the transitioning to an extratropical cyclone as well, you could see some intensification.
Yeah.
Yeah, it looks
Just
like in the
goes to tell
970
how powerful
millibars.
tropic traffic can be.
The faster it goes down
Well,
southeastern, the more it intensifies, I think, is what it's showing here. Yeah.
it's
Right.
interesting on the GFS what it does. I don't think this is actually what's going to come to
And also,
fruition because
this
obviously,
shows it very clearly in terms of land interaction with the storm. The further east you are, after you make landfall, the stronger you are. You can see on the western side, there's a lot of blues here, meaning that's weakened down to around tropical depression status. And then on the right hand side, you get more of the greens, the tropical storm status when it reemerges back out to sea. You can clearly see the split there. There's a line right in between there that separates them. Or oops, um, let me move right there. Okay, yeah. There's clearly a line right over here that separates like where you need to be. The further east you are, and the more quickly south you go, the stronger you will be.
You
yeah,
gotta
or the
take
stronger
into
the system
account,
will be.
Yeah.
gotta take into account that the ensembles on the east side that are closer to the coast, when obviously going through Mozambique, is that their eastern side of the radius maximum wind is going to be off the coast. So
Yeah.
you will
Oh yeah.
see the
Yeah.
winds moving. Yeah.
Yeah, so it's like if the center's right over here, for example, the strongest winds are right along here-ish.
Sure, yeah.
Yeah, of course, right as the storm goes back over the water, it will likely intensify to a tropical storm in this area, and then later on, thankfully, it will be out of the way, so no land areas will really be in the impacts if it does become a cyclone. Zoom out. There we go. How long do you think it will take until it turns non-tropical, Casper?
I mean, give it maybe 4 days.
Oh wow, that long?
Could be as soon as 3. There's a bit of uncertainty, really, when it could finish its transitioning.
Mm-hmm.
I am observing.
Is it a stalled front along here?
Let me observe.
I'm trying to learn more about fronts. Because it looks like it's just going to be north of the front and then it will finally merge with it.
So, mid-latitude trough passes around 50 degrees south. Cold front passes overhead, obviously alongside with it. And essentially takes it southwards as well.
Mm-hmm.
Takes Filipo southwards. And, yes, you have that cold front passing to the south. Essentially takes it southwards.
And then it gets absorbed or like it attaches to it.
It seems like
You have once ridging kind of attempts to build in
Mm-hmm.
as the cold front passes away, but obviously Filipo's coming down with it.
Yeah.
While ridging attempts to build in between Filipo and the cold front that's just passed, that
Mm-hmm.
frontal boundary should turn stationary, but then again, Filipo's already entering the subtropics and mid latitudes at this point, so you will see it transition as it goes along the frontal boundary.
Yeah.
yep.
Transition when should I finish? Probably give it models indicating around give it 72 hours and it'll be done.
Mm-hmm.
Yeah, it seems about reasonable.
Should be a pretty
72.
powerful one. Maybe a cyclone force.
You got such a strong overhead jet, so you will see pretty strong intensification and pretty far west for a system in the Mozambique Channel and leaving it.
Yeah.
For this area in particular, you don't see this very often, as you've mentioned already. Yeah.
What about sea surface temperatures in the area?
They
Actually,
do cool. They do cool, but you should see. I mean, with the upper levels so powerful, and with the baroclinic forcing, obviously aiding in intensification here at this point, temperatures shouldn't matter as much as they would do
Yeah.
in the tropics. You see 26, 27. If anything, for such an environment in the southern hemisphere subtropics, that would probably be classed as favourable, if anything. I mean, with the
Yeah.
environment you're in, because it could be worse. So
Yeah, definitely.
you're in a pretty relatively favourable environment. But they do cool quickly as it does get staking.
How
It
strong
gets
do you
taken.
think it will be when it?
I mean, with this, I mean, cyclone's definitely possible.
Mm-hmm.
I wouldn't expect anything weak out of this, except, I mean, I wouldn't really go full certain because we don't know what could happen over land. It could
Yeah.
go further inland than currently forecast. We don't know. At the moment, doesn't seem it's sticking to the Joint Typhoon Warning Centre forecast cone, so and it's
Mm-hmm.
heading further. I guess, yeah, it's heading more south and less west than
I
it
do wonder
forecast.
if this jog continues for a few more hours. I do wonder if it's going to make landfall on that little island. That little
Oh, this thing right here.
Yeah, I do wonder if it could make landfall on that little island right there, and there'd be 2 landfalls instead of 1,
Yeah.
considering how far south it has been tracking lately.
I'm convinced it'll just pass just to the north. It looks like it to me.
Yeah.
Yeah.
Yeah. I feel like it's just gonna. I feel like it's gonna stay on this cone right here, the edge of it.
Could do.
'Cause it looks like right as the Joint Typhoon Warning Center put out their cone, it looks like it was just a little bit south of it, and so it just continued moving south, or the southern tip of the cone, like this. And there's no radar in the area, right?
No, there isn't.
That's why radars are
But
important.
Mozambique's not that fortunate,
Hmm.
unfortunately.
Yep.
Generally, you absolutely nothing in Africa. You'll see the Mascarene Islands will have radars, fortunately, but
Yep.
that's the only place you're going to see on the continent, unless you want to count the Canary Islands up in the Northern Hemisphere. But yeah,
Hmm.
in the Southern Hemisphere, there's barely anything here. In East Africa, you won't see much.
Yeah.
But I do hope for some useful observations. I'll take a look now.
Right. So there are observations on the in the area.
Should do. Should be.
I forget this thing shows observations as well. Let me see.
It's Mozambique, so likely they're lost. We'll take
Hmm.
a look.
We're here. I don't know when this is last updated, but it shows there's one with the 1007 millibars to the northwest of the storm. Ship observations. Okay, here, let me zoom in more. Oh,
Cool, right.
1005 millibars, I see actually. Ships, I see 1007 millibars near the coast. Buoy, nothing. Right.
Yes.
Oh, wait, we got an ASCAP pass? When was that?
Oh, that was just before 19Z, I believe.
Right, I'm gonna try and pull it up.
I'd
So,
imagine the storm now is getting to the point where it's so strong it might not be a huge resource.
yeah. Well, I mean, it's a good source of wind for Winfield.
Yeah.
That is true. That is true. So, right, so
Oh, we've got a lot of systems active. Okay. 17S.
Feels like an eternity since we've actually had this many systems.
Yeah. Oh, here's the ASCAP pass on it. I see. 18Z. So strongest winds around 45 knots on here, which you could estimate 50 knots. But of course, it's strengthened more since then, and
Oh yeah, quite a
thankfully
lot
this
more.
isn't. Yeah.
it's definitely not even that strong. If we're looking at that, if we're looking at those, sorry, we're looking at those ASCAP passes, right?
This one shows some 50 knot
It's
barbs.
it's very unlikely that, however much you undersample, got to take into account that the core size actually relatively, again, it could say this is relatively small, compared to other systems. You look at this, um, your best bet is to not use these.
Yeah.
However much you attempt to undersample with these, you have a developing core. You're most likely at hurricane strength now. You are not. You are not recommended to use these passes
Yep.
at this intensity. You are not.
But here it does look
It
like
looks
tropical storm force winds are on the coast.
it looks reminiscent of a tropical storm, a strong one.
Yeah.
You will see a lot of these, and it surprises me how even on the 12.5k raw wind version that you have here, that what I'm looking here at, like what, 45 knots here,
And then this
45
one is
knots,
49 knots.
49, right, and it does show to the extent that, not that it's this weak, because it's probably not this weak,
Hmm.
but probably the fact that the radius maximum wind and the size of the core is so, again, it's smaller. It's smaller
Is
than
this the
average.
area of maximum winds right over here?
We are dealing with a pretty small wind field here, maximum wind field
Would
here.
this be it though? Right on this side,
Yeah.
the northwestern side.
That would probably be the strongest winds here.
All right.
I mean, that's if you look at microwave passes here, latest one.
Wait.
Even if it's just the 12Z one that came up and surprised a lot of people.
Can you send it in?
You will see that that will probably be the strongest section of the island.
Yeah, that's where we've been seeing a lot of VHT activity lately.
All right.
Considering it's very slow movement, storm speed doesn't really have that much of a play in where the strongest winds are.
Yeah. There's a decently large city over here. Zai, I don't know how to pronounce it, but yeah, in the path of the exit zone. Hopefully, if it is on the eastern side, though, it won't really impact many large cities if it was like right in this area. The bad news is this city, Vilanculas. The further south it goes, the worse the storm surge for them.
Seems like the Gulf of Carpentaria system's been materializing pretty nicely so far.
This one right here,
Take a look at that. Yeah,
90
it's
something.
blowing up a lot more new convection. Or no, the system over to its east, and like in the Gulf of Carpentaria. Yeah,
This one.
you can see in recent frames as daylight's gone over the system, we've seen a lot of new convection fire.
Here,
So
let me
I
pull
can
it
see
up on
some
Tropical
broad
Temp.
turn in there. I can see some broad turn in there, so that's ideal. It's a good start. Not too bad, actually.
Alright, let me pull up visible shortwave. Yeah, there it is. So, I mean, the sea surface temperatures are warm there, so lots of convection.
It just basically can't stall.
Yeah.
Kind of the rule of thumb there.
This was the last JTWC forecast. They did have tropical storm force winds on shore at this time.
Interesting. What's happening with this one?
But they have the northern side extremely small in terms of the wind field. If I take a look at it here, yeah, I guess so. Not really, though.
Should be relatively equal, to be honest. Judging
With a little bit
off
more to the southern, southwestern
It is
side
more
of
to the
this
southern,
pass.
To be fair, yeah.
But yeah, definitely as of 18Z, tropical storm force winds at least on the coastline.
Okay then.
When should we get an update on the storm, like Mateo, France or something?
Just after Zulu, just after midnight, Zulu.
Alright.
Should see, yeah.
Since this was their last forecast on it, oh, they lowered the, they originally had a cyclone peak as it was going back out to sea.
Did they?
Yeah, they did
they're
at
not-
one point.
Alright, cool. Interesting, I'll take a look then.
How
So
strong do they have as the extratropical point? 14,
I-
22?
I'll observe, and let's take a look.
Alright.
What the first post-tropical one?
Yeah, first post-tropical.
Eh,
Where do you go to see it?
Oh yeah, yeah, that's Hurricane Falls. That's 65. Yeah,
Okay, so they do have it now. Okay, they still have it
they
as...
do have it now, but they have it on the transitioning. Yeah.
Yep, alright.
If you do see post-tropical, that just means transitioning, and then obviously you got the quite clear extratropical.
Oh, the
depression
blue
there.
is extratropical.
The blue is purely extratropical. That's when they think
Okay.
it's transitioning. But when you take a look at post-tropical, that's when it's transitioning or it's losing
Alright.
convection. Typically, that's typically how they do it. Yeah.
Alright.
Makes sense.
What else do they have that we can show?
If you want to see their full in-depth discussions, go into operational products.
Operational
and then
products.
Go over to operational reports, and then RSMC advisories. Analysis
RS.
forecast RSMC.
Where?
And then you'll see there
RSMC?
analysis
Alright.
forecast. And then
This
obviously you
one?
got latest ones, yeah.
Let me
And then you
bring this
get
over here.
in-depth discussions there.
Okay, so. Where is it? Okay. I see right here 64 knot winds right there. And then 65 knot post tropical. Tropical, then extra tropical. Okay. So what do they have it at? Okay, they have it's weakening to an around a yeah, they still have it as a tropical storm over land looks like.
Oh, Chase, you want to observe that latest GFS one? You really do. You need to take a look at it.
All right, which one for what storm?
Uh, take a look in
Australian?
the Australian.
All right.
In the Australian, yeah. Observe the latest
Jeez.
18.
Okay. I see it.
Yeah.
Crazy. Have you seen this
Oh, good lord! Is it
on my
what I
screen?
think it is? Just yeah, okay.
They currently have the peak as 930 millibars, waiting for the newest frame. Probably going to be in the 920s.
Welcome
Because,
to the
Don't put too much
GFS
faith.
run.
Oh, hey Daniel.
Yeah, I've been here a little bit.
Nice. And so as you can see, there's a lot of little lows that the GFS likes spinning up.
Yeah,
Yep, that
of
is
course
pure
it's
convective feedback.
GFS.
Mm.
Pure GFS being, well, you know.
You have a lot of convective feedback there, yeah.
Yeah.
Pretty clearly.
Yeah.
I mean, yeah, and also obviously don't the forecast for what forecast for 18s. Don't take that too much. Don't take that with too much faith yet.
Yeah.
Despite the potential, despite the ceiling is there, I think when you take into account the fact that there is not enough model agreement for something like that, take into account Ilsa didn't end up having the agreement to be this week.
Yeah.
That's pretty good agreement.
GFS
Yeah,
had it as a Cat 5 at landfall.
Don't put too much faith into this yet.
Yeah.
Yeah.
I'd actually yeah.
Alright, Daniel, how long do you think it's going to take for the storm to make landfall?
10,000 years at the current rate.
Yeah.
Feels like it. It's just it's so
TBH.
slow.
Interesting. The Northwestern VHC seem to have dissipated. I'm waiting for some new ones to
look at it.
fire. Or
Vertical hot
Filipo.
tower. Yeah, I see it there. So we should get some nice new burst of convection.
If it doesn't, that might tell you there's some dry air issues.
Yeah. As you can see,
Which I already
like you
might-
said earlier, there's a lot of open areas,
Yeah.
no
Which
convection.
actually, I would say the system already is a little bit struggling a little bit with dry air. It's healthy, but I want you to observe something.
Mhm.
Watch in like the last few hours its general behavior in the convection near the core.
I see it's been fading out.
You see how no, watch every little burst.
Right.
Just yeah.
There's one right there that it fizzles out, another one fizzles out. Like
Do you see
this
any
was
big blowups of convection?
no, or they try to, but then they fizzle out.
That tells you the environment's at least somewhat dry.
Yeah.
Because generally, remember the dry air entrainment that I was talking about yesterday?
hmm
Same issue here. Same exact issue here. Maybe not to the same degree, but like same exact thing. The convection generally can't grow into these huge, vertical hot tower clusters when it's dry like this. So that's why, like, in the Westpac, whenever you see those systems developing, you have these minus 85, minus 90 degree cloud tops extending over a huge area.
In
Just
this area, the
shrouding the whole
max is
center.
like in the minus 70s.
Yeah, and you can see generally that this convection's it's not expanding very far, it's dying out pretty quick. It's
hmm
generally not a very moist environment. Even though, like, it's sufficiently moist to intensify the system, but it's not enough to help it, if that makes any sense.
The intense cloud tops are now approaching the coastline, looks like. Just touching it now.
Yeah,
This is as of the latest frame. This is like 15 minutes old, so.
looks like it's taking another slight jog to the west in newest frames. So I would expect.
Let me look at this again. I don't really see that it moving to the west.
Or slight jog further in a west direction than it's been.
Eh,
Because it seemed like it was moving due south earlier, but you can see that center has been translating a little bit further.
yeah. Here, let me draw that actually. It looks like it was kind of like this motion-ish.
Yeah, I agree. It seems to be something like that.
Let me take a look at Zoom Earth's general motion. Yeah, it looks like that. I do believe it's going to try and stay on the southernmost or easternmost part of the cone most of its life there. This general area.
I can generally agree with that.
Maybe I feel like it's going to be in between the. Okay, can I draw using? Okay, in between the center of the cone and the very eastern part of the cone. I feel like that's going to be its main area. Unless it decides to make an immediate jog to the west.
Yeah, we'll have to monitor how long this motion continues on for.
Yeah.
It's still not moving. It's still moving pretty much parallel to the cone at this point, even with its current motion. So I don't think it's going to cross over
Yeah, no.
like over the other side of the cone. I think that's highly unlikely, but maybe getting a little closer could be.
I feel like it's just gonna stay like this, maybe, possibly. But it all
Yeah.
depends on the jog it kind of makes. If it does make a jog to get over to the center of the cone, that is always possible. Yeah, if the jog makes it go down here, it can always try and jog back to the other direction.
Yeah.
But its average motion seems like it's gonna stay. Nope, wrong line. Okay, if it stays in between the center of the cone and the edge of the cone. It could definitely get out of the edge of the cone, since it looks like it's roughly in this area. Could be trying to leave the cone. Yeah, let me try and see where that center would be if it does do that. Let me go like that. Alright, so yeah, like if this is the center of it, you can see what areas would be hit with the largest amount of convection. Go down like this. So do you think that the size of the convection will stay the same?
Like this generally less potent look where it's
Yeah, like this size, basically.
looking at it. It could have a slightly larger blow up, but I think it's not going to expand too much. It's just that it's just in a very, I wouldn't say very dry environment, but it's in an environment that is characterized by drier than average for tropical cyclones. And notice it's been tracking pretty close to the coast for a while now. So it's pulled out, its winds have literally pulled drier air from the land into its circulation now.
Because it's going like this way.
You say drier than normal? Oh, it's in very dry air conditions. Just look at water vapor.
Yeah.
Yes.
It's like black on water vapor.
Here, let me pull up this. Yeah,
but near the center it's
here.
a little better. But
well,
this is a perfect
poor
example
center.
of it right here. You can see all the dry air around it.
Yeah, that poor sensor be trying to fight off all that dry air.
This is sucking in all this dry air right over here. It did have a blow up of moisture there, so
it's a downslope flow, is what this is. If this was 100 miles further east, it would be materializing a lot better already, just simply because it wouldn't have to worry about that downslope flow.
Yeah, since this area is also all a lot more moist.
Yeah.
So even parts of Madagascar over here has a little bit of moistness to it, but not a lot.
93P really looks solid for a developing system.
Yeah, for this system right here, if I pull up its center on how large it is, If it remains this kind of large size
I'll show
or
you
small
something.
size, and if it keeps going on the southern part of the cone, the edge of it will go out over the water. So,
So I actually want to show you something, Chase.
hmm
I'm going to show you how you can basically identify the axis of a wave just by looking at it, okay?
yeah,
And I'm going to do it basically by annotating with arrows. You have flow like this, and you have flow like this. And then you notice what the line of the convection is. So
hold on.
like this.
Wait, which storm are we talking about?
I'm talking about 93p.
All right, 93p. Let me pull up visible shortwave.
Ooh. Oh, yeah. Pepper. So here. I DM'd you the image.
All right. Yeah, here, I'm going to pull this up on stream, the image.
So generally what I'm showing here is the wave axis.
Yeah, how it's tilted.
Yeah.
And then you can see the direction of the circulation somewhat. It's not exactly straight.
But you can generally see, like, this is kind of how the tropical wave is trying to close off currently.
Yeah.
Hold on. This is not a tropical wave.
Well, yeah.
Or whatever.
Just
Tropical-
standard monsoon trough disturbance, yeah.
Yeah, disturbance.
But yeah. A lot of blow up of convection right along this area. Right there's. But yeah, I can see the circulation right over here moving through, and then I can see the winds down here. Has there been an ASCAP pass for it?
I can see.
Alright.
Take a look.
Tropical wave, yeah, but disturbance.
All these
Um,
storms pretty much have an open center. It's the main one that we're talking about right now.
All of them what?
They all basically have open centers,
Yeah.
except the one that's about to be making landfall, and that one
Well,
still.
18 doesn't have an open center.
It does,
you
I
know.
think. 18S? Or,
No,
I
it
meant
do-
like the
it does.
convection.
So 93 had a ASCAP pass that missed
Oh, man.
around 13:2, and the next one would be just after midnight Zulu
Right.
time. I'm not exactly sure if that's going to be passing or not. I mean, I could take a look. But last one missed, and it was a while ago, so just wait for the next one.
Alright.
Yeah. I'm generally just using surface, like, or at least the winds, using cloud streets to be able to determine somewhat of what the circulation looks like.
Cloud Streets?
At this
What's
point.
that?
So when you're looking in the low levels, you see the little cumulus clouds.
Here, let me go back over to that system. This one, right?
Yeah.
Oh, Cloud Streaks.
Yeah, like look over the Gulf of Carpentaria and you can see the direction the little cloud streets are moving,
this.
especially on visible imagery. That can tell you generally what the wind direction is.
I see
So-
those moving that way.
Yeah, like the low level cumulus streets, they'll look like
Oh, this
little
stuff right
lines.
over here. These lines down here. This is what you're talking about? These things right over here?
a bit further north.
Okay.
Let me send you an
Like
image.
this right here. I can see them. Like, here, let me zoom in. This stuff, right?
Yes. You
Moving
can see
that
these
way.
little lines of cumulus clouds. Those can kind of help you out if you want to know what the center looks like or the circulation looks like without having to use an ASCAP pass. You
Yeah.
can sometimes use those and the direction they're moving, and it'll kind of tell you somewhat of what the circulation looks like.
Yeah.
Also, Chase, a little off topic from the tropics, but I did want to bring it up.
We're trying to
while
focus on the tropics right now.
Okay, never mind then.
Let me guess, it was severe WX related.
No, it's the fires all over the place. In the
Oh,
US
okay.
that are going out of
yes,
control.
fires, yep. But yeah, it should be like the storm should be making landfall within the next, I don't know how long here. I'm gonna see how fast it's been moving recently. If it centers roughly in this area, and this was 6 p.m., and then this is, I don't know what time that is. It's around 50 kilometers. That is 2 p.m. So it's moved around 50 kilometers in the past 4 hours. Kilometers, or divided by 4. It's around 12.5 kilometers per hour, or do miles per hour, or around nearly 8 miles per hour. So has it sped up some?
Um,
It's gone from around 10 kilometers to around 12 kilometers per hour.
Surprising it's really sped up. Felt like it was moving very slowly, but I guess
Well, it's basically gone from 7 miles an hour to 8 miles an hour. Not much.
yeah.
And let me compare it to the coastline. I don't think it's going to move north at all, right?
Yeah, it should definitely not move north. That would be
Yeah.
really weird.
It's around 50 kilometers to around 70 kilometers. So it's cropped down 20 kilometers of distance since we started around an hour ago.
At the peak of this
Or
was.
90 minutes ago. So if at most it's around 50 kilometers up until its landfall-ish. Or wait, no, hold on. Let me find the center.
Um, should never mind.
Now, I could definitely get out of the cone, though. That's the thing. Because the main landfall site has to be somewhere in. Let me grab the center right around there. This is mainly the area, right? Because it can't move east, it can't move north as well. It has to hit somewhere in here. This is the area that it looks like.
Yeah. Oh, I see what's going on. Wow.
What?
Um, oh no. Daniel's image.
Oh, yeah, all the fires, yeah.
Take a look. He also mentioned too is looks like you do have more thunderstorm activity on the southern part of the center that's developing with that band.
Oh,
Um,
which bands?
with Filipo that is moving onshore currently. Only
Oh,
little thunderstorms right now, but they could grow upscale into a larger banding feature here soon.
are you
Getting
talking about
onshore.
these right here?
They
These
should be
things that
south
are
of the center.
this stuff, right?
Yeah,
Oh, you're
generally
pushing
associated with that
onshore.
band. You could see.
Onshore. Let me zoom in closer. Nah, closer doesn't. It kind of does. Um, but yeah, I can see
You
it
could see
right
the
over here.
formative. Yeah, you can see the formative thunderstorms pushing onshore, even a little bit further north than that too.
Yeah,
All
right
of it feeding.
around here.
Yeah.
This stuff is continuing to wrap around the center, so it's moving onshore. Let me see if I got anything that can. I want to try and show like what's actively ongoing with in terms of rainfall, stuff like that. If like I know that my radar shows it and weather.com shows it. Like a rough idea. Let me see if I can turn on. Um,
Right. Probably gonna make my departure now, but yeah, no, you guys have a good stream.
nice. Thank you. All right. See you
See
later.
you later.
All
See
right.
you.
Daniel, can you send in the picture from like my radar showing the convection or like the estimated rain on what it looks like? Oh, never mind. He left. Okay. So, I'm gonna try and pull up weather.com. As,
Uh,
as that should show a general
I
idea on it.
got
Where's radar? There it is. Okay. Just trying to get to it, and then I'll pull it up on stream. It somewhat does a good job, in my opinion, at estimating. Okay, does it show it? 24-hour future radar. No, okay. It just appeared briefly. I tried to press on it. Okay, I don't know if you saw that. Yeah, right there. It appears very briefly. Okay. All right. I'm gonna pull it up on stream now. Right over here. This is. Okay. No, let me go zoom out of there. All right. Right down here. For whatever reason, it doesn't like showing the tropical cyclone. All right. There it is, roughly right now, ish. Would you agree? Kind of
Hello?
forming an eye right there.
Yeah, this is a pretty classic formative core. Although, look to the southeast side. Remember how I said there's a drier intrusion?
Yeah, right over here. There's an area of dry air, roughly.
Yeah, very clearly a drier intrusion.
Yeah,
So
you
that's
can see
probably
the
what's preventing it
banding
from
right
intensifying very much.
around here. That's kind of formed. But also you can see the dry air intrusion.
Yeah, it's causing some pretty
And
clear issues to its
so
core
this is
structure.
roughly right now what it looks like. And then if I go in ahead an hour in time, looks like it's almost made landfall at that point. Still, the
Yeah.
southwestern side looks like it's the wettest at that point. You can see all the dry air over here. And then another hour
Yeah.
in.
Remember that this isn't very. I'm not going to say it isn't very accurate, but
It's meant as like a visual representation, kind of.
yeah,
It's a simulation,
kind of.
roughly.
It definitely isn't super accurate with
Yeah.
how it represents stuff sometimes.
Might make landfall within the next 2 hours. But yeah, you can see the banding there still to the northeastern side. Heaviest rainfall possibly on the western side of the storm. Do you think that's accurate?
On the western side of the circulation, I think likely it will be.
Yeah.
Actually, I think it'll be on the west side like sooner, and then as it gets on shore, I think it's going to transition to being more on the east side of the circulation. Usually, what happens is when it makes landfall, is a lot of the banding concentrates near the coast.
Yeah.
Um, because of where the storm wants to grab moisture from. So you need to be looking out for once it makes landfall, you'll see a lot of convection flare up on its east side.
Yeah. Right, this is roughly 3 hours. And
It's a very typical evolution for storms that make landfall. They
Mhm.
almost always have a huge band fire on their east side, or whatever side is offshore.
yeah. Right, this is around 5 hours down the road. They're still kind of struggling there to move any bits, and you can see that banding to the east side could try to form. And we still have this band right there that's I feel like should be fizzled out at this point. I don't know if it will last that long. What do you think?
No. That band way out there, it depends. We'll see the banding offshore definitely amplify once it makes landfall.
Yeah, but this is the
That's just
banding
very
that
common
starts over
evolution
here.
with
It's this band
with
right
storms.
here.
Yeah, I mean, I could see it. It's just that as soon as it makes landfall, like, oftentimes it is that like one of those bands that'll probably just get very strong. It's a very common evolution to see.
All right, now this is a 24-hour kind of estimate of the rainfall. Let me see if I can. Okay, yeah, rain. The red is the heaviest there. This is roughly an hour by hour view. Can I go like this? No, okay. Yeah, so definitely right along the coast is going to be the strongest area of rainfall, and then this is the end of what we were looking at before. This kind of shows a general idea of where's the heaviest rainfall.
Yeah, picking up on that offshore band, I see.
Yep, all along the coast is where the worst is.
You'd be
So Vilanc, that city, Vilanculo, or that city, trying to get a rough idea of the rainfall there. The heaviest should leave in around 10 hours or so, but definitely still moderate to heavy rain could still be occurring. And then the rain ends in around 24 hours ish. The It should be just light rain at that point. Now, what's a larger city that's in Mozambique? What's that? In Hambane? I think we looked
I'm gonna
that
be
up.
honest, I don't really know that many cities in Mozambique, so
In
I don't
Hambane
track very much over there.
population. That city has around 80,000 people, so that's definitely a larger city. This one right here. All right, so let me pull up its somewhat forecast. Maybe getting some rain right now. I'm going to try and pull up satellite on it. In Hambane is right around here. So do you think that I could be getting some rain right now? Definitely, right?
Um,
As well as
oh
this
yeah,
band starts heading inland.
we have a lot of areas that'll probably get quite a bit of rain from
Yep.
this.
So then, of course, the rainfall rate is just going to keep picking up and picking up, just getting heavy rain, and then yeah, so it's basically just going to be downhill from here, and maybe start clearing up within the next 24 hours. But definitely going to be in the this red zone for like the heaviest rain, flash flooding potential. Let's see, there's trying to look for another large city. There's Maputo. I'm gonna search what that is. Okay, that's a city of 1 million people. The capital of Mozambique is right there. See it?
Yeah.
Alright, so
Let me see.
right here, this has around 1 million people in it. The capital.
Oh wow, so that'll be closer to its path once it gets offshore.
Yeah, here, let me pull up a loop of that area. Here, I'm gonna pull up on what looks like right. Okay, we can't really see there. Let me zoom out a little bit more. They are right around here, so it doesn't seem like they're getting rain right now, right? Just some
No,
clouds.
not too much.
And if any rain, it'd just be very light at that. But now let's play the loop, try and see just a rough idea. And so it looks like the edge of the rain starts coming in at around 6 hours. And then more heavier rain within the next 24 hours. Oops, let me back that up. Alright, hold on.
Yeah.
Alright, that's 12
Well,
hours then.
these maps are generally very hard to get the exact
Yeah.
rainfall placement and amount just because we don't have the data really over there to see clearly where the heaviest rain is going to be at all times.
hmm
Um,
It's a rough idea. I like this radar thing as well, since it shows you just some like 4 different colors, just so you could kind of get a rough idea
yeah,
on where it is. Anywhere in that green, though, can get some heavy rainfall. All just depending on where it moves. It could get some rain within the next 6 hours, and then within the next 12 hours, some of the heavier rainfall rates. And then the reds there, the very strong rates, could definitely occur within the next 24 hours. That's all we see right now, just along the coast as well, as you can tell. Right along here, just areas of very heavy rainfall, and then this area could be some amounts of moderate to heavy rainfall. That's within the next 24 hours, roughly, on where it could be. Right. What about how moist this area is? This is all thunderstorm activity, right, that happened earlier?
um, yeah, that is generally thunderstorm activity, but it's not.
And we're heading into D-min, right? Or because,
Yeah,
like,
so
all of it's fading out now.
yeah, all of the convective activity over land is fading out, and then all of the convective activity near the center of the storm is actually percolating up. So yeah, you're right.
Alright. Yeah, since as those thunderstorms were brewing and stuff, this was forming as well. Then as they were dying out, this is starting to fizzle out.
Yeah, you can see the inverse relationship.
Yeah. Right. Any new updates on the vertical heat towers? Nope, doesn't seem like they're doing anything. Just fizzling out even more right now. Right. Crazy.
Yep.
What about this line right here? I'm noticing how there's a very quick gradient from here to here.
That's just probably Cirrus
Right. But dry air as
or
well, right?
Anvil expansion. What?
Does this also show dry air, I guess?
Um,
Because
yeah,
it's not
that
going
all
that
that
far.
shows is just high clouds overspreading dry air below it.
Okay, yeah. Yeah, I do like how you can very clearly tell where the dry air is in the storm. It's sucking it out of the land. Right. Yeah, it's really starting to fade out here. Depaya does show more updated imagery, right?
Typically, yeah.
All right. Is this it? No, this is. Yeah, here we go. There's what it looks like roughly right now. This is um 15 to the okay. This is 30 minutes old. So let me look at the tropical tidbits imagery. No, this is actually more up to date. Oh look, there it is. There's another one. Vertical heat tower, right
Yep. They're refiring. Yep.
over there. Took it a while. How long did it take? Like 2 hours or whatnot to start firing up another one?
Um, no, not 2 hours. I would say maybe like 45 minutes to an hour.
Right. Oh yeah, I see. Yeah, right there.
Really only a few frames, which isn't really too
Yeah.
bad.
But I'm talking about like since the last new burst was
I've
around
seen
here.
times where tropical cyclones will take like 4 hours to fire new ones, so it's
Yeah.
not. That's not really too alarming. In fact, in most RI phases, you'll have a period, or you'll usually have periods where it's like 1 to 2 hours of not too much happening, and then it
Yeah.
fires up new convection.
Do you think that this will
Else,
make this center once again towards the minus 80s?
there's a good chance.
All right. Or do you think it's
It
just going
just
to be
depends on
fizzled
if
out
they
in the
really
next
fully
frame?
materialize or not. Notice they're pretty pimply still, though, so they shouldn't make a huge burst.
Yeah.
Um,
Yeah, this one was a lot larger near the center, and that's what caused that. This one's a lot smaller.
it is also early, so
Do you have
we'll
any
see.
other websites for imagery? Like Real Earth, I think that's one. Is this one?
For imagery, I really do.
And this is Meteosat, right? Meteosat.
Yeah.
Is this 11 or 8? Okay, it's 11 right here. Found it. Sorry, I was just trying to figure out which one it is.
Yeah.
This was as of 22Z, so oops. Okay, this is an hourly thing. You can see the evolution of it. And let me add another one as well on top of it. Alright there. Now let me add more frames to it just to try and get like a 24-hour view of it. 24. Hopefully this doesn't crash. Yeah, oh wow. Take a look at the difference 24 hours make.
Yeah.
Get the new frames as well.
I want to see what helped wrap around.
Trying to load the rest of it in. There we go.
Yeah, it looks like it had some very good convective bursting.
Yeah.
Help.
Now it started to fizzle out.
Yeah, just because convection fizzled out, that doesn't really mean that much in the
Yeah.
grand scheme of things.
It's mainly just the whole Dmin Dmax thing, right?
Well, no, this isn't really associated with Demon or Dmax. This might just be a brief dry air intrusion of some sort.
All right.
Like what you saw in the radar imagery, probably
Yeah.
accounted for this.
Here, I do want to check again if they did have it organizing some at all. Can I see the previous loop? Okay, I guess not. Alright, so do you think that this will show organization? Or, here, this one right here. Does this show organization of it, or what do you think?
That?
Yeah, this.
Um,
Let me play it again right here.
a bit. Shows all that shows really is just becoming more bandy and then also concentrating to one side once it makes landfall. And you can see the bands offshore that are starting to ramp back up.
Yeah. Also, I can see this right here, the band just continuously funneling heavy rainfall rates.
Yeah.
Wondering if there's any other models like that that I can pull up.
Not really. It's kind of hard to get good imagery on there.
Yeah, this model at least shows it's kind of making landfall within the next uh, 2 hours, I guess. I guess that's possible, right?
Yeah.
It's also mainly, though, that they might think that the center's right here, when in reality it's in this general area. Right, I don't know why that popped up. Okay,
I want to see what this VHC does, and then hang on my hop off here.
right. The frames take how long? They're 15-minute imagery. So it takes like 15 minutes for it to load. What about the International Space Station right now? Has it passed over it at all?
Take a look at this environment near this Gulf of Carpentaria system.
Okay, no, it's not. It's not even close to the storm. The
Oh, wow.
ISS. It's on the other side of the hemisphere. Just checked off screen.
I think we're going to have to watch for an overperformance in the Gulf of Carpentaria system, to be honest.
Yeah.
It really doesn't have that bad of shear for a long time.
This storm, right?
Yeah, what you're seeing in the Gulf of Carpentaria.
But that is going to move out of the way soon.
Yeah, but I'm saying, like, if you take a look, there really isn't much shear at all in this environment, and it's not going to rise very much for a long time. And considering it's moving mostly east, or maybe, east-southeast, it's not going to be leaving the warm waters associated with Gulf of Carpentaria or, the South Pack for quite a while.
Yeah.
So I would
I'm
be watching
interested in
for
seeing the new system that tries to move in.
which one? 18?
No. There's this little area right here in the timer C. This is the one that all models want to form in the Gulf of Carpentaria within the next 5 days. This is the one that I was showing you with Euro and stuff like that.
Yeah, I see what you're saying. It has to move over land first, so we have to see its brown ocean.
Yeah, that's
Seems
what
like the
I'm saying.
GFS is actually backed off of it forming.
Oh, here, let me take a look. And in the beginning, they didn't show its forming in the last run either, really. See it? Kind of in the 10-day range, but GFS, for whatever reason, I guess it's just because it was near land. But yeah, Euro shows it's going in the Gulf of Carpentaria within the next 4 days. And quickly developing. And then CM's, the Canadian model, has it entering in the next 4 days as well. The Icon model. Who develops the Icon model? Or who made that?
I'm not even sure, to be honest.
Yeah, it shows it reaching it within the next 3 days, actually, 3 to 4 days. Who made the NavGem model?
Navgem?
Yeah.
I don't even know who made like some of these other models. Like,
Mm-hmm. NavGem only almost wants it as a storm right now, but this model is quite inaccurate. Yeah, another thing is, why did Lincoln weaken so much when it was over, or when it was back over water
Lincoln.
this year? The storm
Oh,
that went like this track.
I think it was sheared, if I remember correctly.
Right. Yeah, I'm just wondering if that happens to this new system right there. I don't know. Because it's in this area as well.
Yeah.
Models showed Lincoln being just like this. Let me look at cyclonic weather as well. This right here, model data. Like how this shows you a general idea on what this shear looks like in storms. Here's Filipo. You see how the
Yeah.
convection is lost, they think? Which I don't think that's going to necessarily happen.
Because it's over land, it will definitely lose quite a bit of its
Mm-hmm.
convection.
And then right over here, you can see at this point it's interacting with dry air. This is within the 60-hour time frame, and there's the wind shear right there that it has to deal with. And then starts turning post-tropical, then it's out of there. Alright, so let's take a look at the 18. This storm right here. Very moist environment right on the northern side. But it has the
Yeah.
shear right there. That's the problem. GFS there. Oh, never mind. They did not go to the 920s. They stayed 930 millibar and then stayed in the 930s. But that's due to a very steep decrease in wind shear, right?
This intensification, yeah.
Well, take a look at the infrared imagery there.
Yeah, that's a very favorable look for infrared.
And let's take a look at last run.
It's not as favorable as Ilsa.
Mm-hmm. Yeah.
Ilsa had a run where it got down to 882 millibars, so
Mm-hmm.
which I actually have a satellite image saved of that if you want to see how
Nice.
ridiculous
Sure.
that looked.
This would be absolutely insane if this were to make landfall like that.
Yeah, I've seen crazier things.
Oh,
Ilsa
yeah.
was crazier than the system's ever going to be.
Yep. Here's 93S right here. It shows it possibly develop. Do you think it will develop before it hits Queensland?
93S, you're saying?
Yeah, 93S, because it's going to strike within like the next 36 hours. This storm right here.
I mean, It looks like it's still quite a bit away from actually forming, but I could be wrong.
Mm-hmm.
What did I DM you?
I don't think that's shears much of a problem with this, right?
No, shear's not going to be a problem
Because
with this
convection's already over the center, roughly where it is. Just needs to develop a better circulation.
Look at what did I DM you?
Huh?
What did I DM you?
Okay. Oh, sorry. Take a look. Oh wow. Yeah. Jeez. Alright, let me take a look at the other storm as well, 92p. Right there, yeah, not really doing much. And then it just starts merging. Oh wow. Look at that extratropical transition right there. from some sort of other system. You see on the bottom right?
Wow. Yeah.
That's nice. All
All right, I'm
right.
gonna see what the speech looks like, and then I'm out of here.
All right. I did want to ask you about the El Nino or the La Nina part.
Okay.
How long do you think it's gonna take until it finally? Here, pull this. How long do you think it's gonna take to finally fully kick in?
It's going to take quite a bit. It looks like actually La Nina is struggling a little bit because of another warm surge from the.
Right there.
It's going to take a little. Yeah, it's going to take a little while to start in earnest.
Mm-hmm.
Um, right now we're kind of in a situation where it's really warm at the surface, but it's really cold underneath. So
Yeah.
we need to see. This is kind of a determining factor this next couple of months.
Mm-hmm.
I could see it waiting until as long as July or August, and I could see it wait. I could see it happening as soon as probably May 15th. So
And this is the trend, right? Or how does this stuff work? This right here, Nino, and like Nino 1 and plus 2. Where's
Nino
that
1+2, you can see that's been rising, but your Nino 3 and 4 are
falling?
important
Yeah, I
for
see.
El Nino mainly.
So where is Nino? Hold on, let me pull up Enzo regions.
Nino,
There we go.
okay.
Okay.
Nino 1+2 is near the coast of South America. Nino
Okay.
3 is a little bit further out, and Nino 4 is all the way out closer to
Right.
like.
And that's how strong it is, right? The like based on how far it shoots out.
No, not really. It's how much of a temperature deficit there is.
All right.
How much of a temperature deficit or peak there is.
Mm-hmm. So this rose right back up again, right? Or hold on, which one is this? That's Nino 1 plus 2 right there.
Yeah,
It's been struggling
had a bit of a
somewhat to shoot.
spike, probably because of. I'm not sure what it had a spike from, but it did have one.
Mm-hmm. This one, they're the same thing here. I don't know what the difference is between these two. Pull them up. That one and this one. What's the difference between these two? This is... Oh, this is climatology. And this is actual value of sea surface temperatures. Okay. And this is the anomalies of them. Okay, so on the right's the anomalies. On the left is what it's looking
Yeah,
like
I'm
right
all out
now.
here.
Okay. Have you seen
Uh,
the vertical heat tower yet?
Yeah, I've seen it.
Oh yeah, I see. There's another one, right?
Well, yeah, that's how they always do it. There's always two, one on one side, one on the other, pretty much.
Okay. Right.
Okay.
Thanks for your help on the coverage.
You're welcome.
Do you think
Yes,
you're
sir.
gonna join back?
Maybe late, but we'll see. It might be way later tonight. I'm not sure.
All right. So yeah, thanks for the help.
Depends. You're welcome.
All right. See ya.
Yeah.
All right. So now we're continuing the coverage of Cyclone Filipo, of course. We got two new bursts of convection right over here. Vertical heat towers is what we call them. Trying to form around the center, so we can clearly tell the center's right in that area. Let's turn up this imagery over here. Get another idea. Yeah, here's what one of the bursts looked like from before. And now we should be getting some new ones. They're not really visible here. On an infrared we can tell where they are. Here, let me pull it up on real Earth. Let's see if this no, it wouldn't have it. Alright, here's a good look on the past 24 hours on what it looked like when it fully loads. Alright, hopefully it... Here, let me go back here. Earlier in its whole life, you can see how it was heavily sheared. There wasn't anything in the center of it. But you had to wait until it finally started wrapping around the center to finally start quickly, rapidly intensifying. So now in our analysis, it's a Category 1 cyclone. It is struggling a bit due to dry air. It's mainly just sucking out the dry air from the land over into the center of the storm. You can clearly see it in this frame as well, just wrapping around the center. I mean, the center's been mostly moist there, and it's been trying to break that dry air that crept in. Let me do it like this. Yeah, right there was the dry air intrusion, and then you could see the banding that formed right as it was trying to do that. So now it's a little bit more moist. But yeah, what a difference 24 hours makes. Goes from that to that, or that, from this to that. So if you have any questions about the threats, please let me know in the chats and I will read it. Alright, so the rainfall threat of this, or first off, I'm going to cover the storm surge threat. If the center is like truly right there, which it might be, um, this is kind of what the conditions look like overall. Could get some areas of 135 km/h wind gust in some areas. The city of Vilanculas, you can get around 130 kilometers an hour as well. If this is indeed the center of the storm, then you can see how this pushes the water, the ocean water, on land. And that's where you get the storm surge, right along here, there. But then in the northern side, you're funneling away the ocean. So that's why you don't really get much storm surge in this aspect of it. You still get heavy winds, but just the storm surge is worse on the southern side. Now, if this continues along, could see a landfall in a couple of hours. And yes, the strongest winds are funneling still in the area right there. Should gradually weaken a bit, and then, as you can see though, this is a long-term threat of possible storm surge still in this area. Basically, all along here, you could get some storm surge going on. Thankfully, it's going to be out of the area pretty quickly. But once it reaches the water again, it could definitely strengthen very quickly. Looks like it might even get to a hurricane force system right along there, and then it starts moving out of the way. You can see some areas nearly 180 km/h wind gust, wind speeds of around cyclone force. But yeah, really not good situation right now. But yeah, wind gust right now, I wouldn't be surprised to see hurricane force wind gust in Vilanculas. So yeah, let's take a look at the precipitation forecast right now. This is roughly what it's looking like right now. Of course, it's not exactly all that accurate. But yeah, we got the band on this side, and we got mostly on the western side the heaviest rainfall. Could get an inch per hour. And then if we keep going in hour by hour, you can see the areas that get the heaviest rainfall. Then it starts moving along. Then, of course, the southern side is going to be the strongest when it reaches the out to sea again. Western side. There it goes. Now, places like, let's take a look at these areas, like Vilanculas. It's, of course, raining heavily right now. It should lighten up within the next 12 hours. In a place like in Hambane, this area could be getting some light rain right now. As we go on into the next 12 hours, they're going to be getting the heaviest rainfall they should out of the whole time, roughly. Maybe even heavier within the next nearly 24 hours. Or the 18 hours, but within the next 24 hours, it should start clearing up. Now, a place like the capital, Maputo, could be getting some light rain. And then within the next 12 hours, the storm starts heading their way. Thankfully, it looks like if the storm's staying over here, they should be mostly clear. But here, if I draw that again, like this, just to show you all the heaviest rainfall on it, if the center shifts from being over here to, let's say, 100 kilometers to the west, you could be getting some of the heaviest rainfall rates. So just still be prepared for that. I'm not anticipating that, but I do believe it's going to be on the eastern side of this line is where the center will hits. Even if it's on this side, you could be barely clipped in on the heaviest rainfall. But if it does stay on the eastern side, it should be fine there. All right, now let's talk about rainfall totals. Uh, all right, here, let me see if this model has an update or anything. Nope. All right, so rain accumulation. Here's roughly what it shows within the next. Here, I'm gonna do within like. This is a higher resolution model. Shows what it should be like within the next 12 hours. Totals around 8 inches, 7 inches. Definitely over 200 millimeters in some spots, and then within the next 24 hours, could get areas of over 300 millimeters, like over a foot of rainfall occurring in some areas. But like it may not be here, it may be over here, maybe on some of these cities. It's just we'll see with observations and stuff like that. But other models like the Euro within the next 3 days basically shows what areas will likely get the heaviest rainfall. Green means you could get some localized flooding, isolated flooding mainly. Yellow is where it's more likely to occur. You could get some flooding in the area. Maputo is included in this area, so they need to be on the lookouts. Could get around 3 inches of rain, or 4 inches, around 100 millimeters possible. GFS shows it being less because they believe it's going to move faster. Icon model shows it more to the east, and this is what I believe is going to more likely happen. But definitely some flash flooding near the coastline, and mainly on the eastern side should get the most rainfall. Basically, anywhere along the coastline in this area could receive heavy rainfall amounts. Um, Anywhere in the yellow, basically. Alright, now, that is the flood threat right now. I do want to show you all the pressure. This kind of shows where the center is moving. Oh, but okay, there we go. This is where the Euro shows the center moving very close to the capital city, Maputo. That would be kind of worrying if this were to happen. Could get some wind as well. Let me pull this up. Around there, you could get 45-mile-an-hour winds. Tropical storm force. Yeah, it does look. I do believe that the icon model does this best right here because of where it is right now. They believe it's going to be making landfall within the next 5 hours ish. So yeah, let me pull up the wind as well on the icon, just showing you all. The green is tropical storm force, so it could likely stay a tropical storm for most of its time there, and then when it goes back over water, it should strengthen more. Then even a hurricane peak cannot be ruled out over here as it's starting to transition into a post-tropical cyclone. The front is right over here, if you can tell, where the winds start merging into the same spot. Like right there and right there, that's the front. And when that finally starts connecting with the system, goes into the center of it, then it will turn post-tropical. Let's see if there's a better example. Yeah, right along here is when it's then post-tropical. Right there, and then just connects to the center of the circulation. Over here you can see the front right along here, connecting into the center. So yeah, the system overall, it may become a cyclone again when it goes back out to sea. It all depends on how the system, or what the system eventually does. Let me take a look at something as well. Um, Hold on. Nice. Okay. All right, and this was the latest ASCAP pass. This shows us roughly what the winds were like. Of course, it's a lot stronger with this. Add around 5 knots to the scale, and then you'd get what roughly where you're at. Maybe 10 knots in this area. This is likely where we're expecting the cyclone force winds to be, and this is as well around 6 hours out of date. So the storm is roughly in this area now. So the heaviest winds are likely occurring onshore right now. Tropical storm is this brown-ish, mainly this reddish color as well. Um, so yeah, definitely occurring for a large portion of the coastline. But yeah, the circulation is very large as well, if you can see in this area as well. Alright, let's take a look and see if we get a new frame. Got a new frame on the storm, see if we can see the vertical heat towers better. Yep, right there. We got a new frame right there. Right there, you can see the difference it makes. A nice looking burst of convection occurring right there. And these two bursts of convections need to try and wrap around the center. It depends on if they're able to successfully do that or not. I don't know if they'll be able to. Like right over here, there's the center, roughly, of it, since it's in between the two. This is trying to create an eye wall, basically. And it looks like, and these are some pretty good thunderstorms as well. Over here, thankfully it's out to sea, so it's not really impacting anyone right now. Right here, let me take a look at the satellite imagery I have. Just to try and check if there is if I can pull up the latest frame. Let's see, right there. Nope, okay. Just trying to see if the newest frame loaded yet. Like, just trying to check if the 23Z frame has loaded. Okay, this is what it looked like roughly an hour ago. The center's in there, had a good ring of convection, but now it's starting to fizzle out a lot more. I do like the fact that you can see the distance from landfall, roughly at this point. Roughly around 80 kilometers it was, but now it's getting even closer to the coastline. Alright, so let's take a look at what else. Alright, let's see what else do I have. I do want to talk about some of the other systems as well. We got multiple of them ongoing. We got 18S, which could be a threat to Australia later down the line. I don't believe this is currently a tropical cyclone. It definitely will be pretty soon. Okay, the satellite imagery is just starting to show its center. But yeah, I'll show you all a general loop of where it's heading. As you can see, it's moving this way, but the convection and the initial part, which was right around here, to then here, it's not really catching up to the center. You'd like the thunderstorms over the center for it to be classified as a tropical cyclone. Yeah, but yeah, right now it's not doing that. So soon it should, and it should become a lot better organized. There is a big if it does happen to strike the coastline of Australia. The Joint Typhoon Warning Center has it not hitting land. They believe it's just going to curve towards it, and then, this is the 5-day point, so there could be tropical storm force winds impacting the coast on their forecast, but here's what it looks like in a cone of uncertainty. This is the area where you could be receiving tropical storm force sustained winds and gusts, possibly higher. But they believe it could almost be a cyclone force system right around here, 70 miles an hour. You need to be 5 more to be a cyclone. So also 65 knots is a cyclone. So it's very close to being a cyclone at the end of the 5-day period. Also, if you notice, they have it sustaining the same winds for around almost 2 days before then a day basically, a day and a half before they start then increasing it, and then it starts increasing exponentially. So instead of it being a stagnant line for intensity, then it starts increasing, and then it starts increasing more and more. It's going to have a difficult time wrapping around the winds or the convection over the center. Here, I'll give you all a good look. What it looks like right now. But yeah, should be according to their scale, a Category 2, maybe even a Category 3. That can't be ruled out. But yeah, here's what it looks like right now. You'd want these thunderstorms to be over the center. You'd have to move that. And basically, once that starts covering more and more of the center, then you can start classifying it as a tropical cyclone. It definitely should be. I'd give it around 100% chance. I'm going to be posting new graphics soon at the 00Z time, so that's in around 37 minutes. So yeah, very soon there should be a new outlook that I'm going to be posting, just giving a general rundown of all these tropical cyclones. But yeah, right over here we got two other systems which could try and develop as well. Queensland, northern Queensland, mainly this part right here, needs to be on the lookout for if this system tries to develop before hitting land. But yeah, then afterwards it's going to be going out to sea. I do believe that this could be classified as like a potential tropical cyclone. It all depends on how quickly it develops. Taking a look at this will show you all a general rundown on the model data on these storms. Here's Filipo. The winds are definitely going to be strongest on the eastern side after it makes landfall, just because it's along the coastline. Then definitely start strengthening and then turn frontal when it's south of Madagascar. But yeah, it could be close to becoming a cyclone there. Right over there, they basically have it as a Category 1 equivalent. Just gonna see how long it takes until it turns post-tropical. Alright, next system is gonna be Tropical Cyclone 18P. Now this is a problem this global model has, is whenever there's a lot of convection or a lot of thunderstorms, they believe it's quickly intensifying. So this run of it does have it as a Category 4 system. Here, definitely a major cyclone, but yeah, it's a big if whether or not this does happen. I don't think this will happen. Just keep that in mind. But yeah, this is a possibility, very slim chance. And even if this does try and happen, the storm will likely curve away from there, going that way. But yeah, the GFS is way overdoing it, just so you all know. I don't believe it to be this strong, but definitely a cyclone. Now Tropical Storm 8, was it Invest 93P? This is the system that's currently by the Gulf of Carpentaria. This system could develop as it heads towards. Wait, is this a new model run? Yes, it is. Okay, that is a new model run. All right, so this new model run, they have it. They don't have it developing as quickly or reaches. It might be a tropical depression or something. Doesn't seem like a tropical storm, but then afterwards it should develop as it heads towards New Caledonia, but turn post-tropical before going towards it. You'd see all this convection, these clouds, just diminishing right beforehand. Alright, let's see what else is going on. We also have another system that may be impacting Vanuatu soon. This is... it's not really doing much right now. This storm right here, it's mainly fizzling out. It's south of Fiji right now, but it might deliver some heavy rainfall rates to the area. I don't know what that is. It may even this is all convective feedback, like I was saying. Whenever there's a lot of thunderstorms, the GFS wants it to be a strong storm, basically. It does become a nice post-tropical cyclone, which is cool to see there. Alright, let's see what else is going on with this. So right here you can see the vertical heat tower right on this side, and then there's another one over there fizzling out. It just mainly depends on how strong this gets. There's a lot of dry air in the area. I'll show that to you. Let me go to satellite imagery, my bad. I'll show it to you here. Alright, now the red is very deep, high clouds. The green is moist upper levels, and the blue is moist lower levels. And you can see how they all, when you get to the white, that's when you're basically moist everywhere. So, and the black is dry on all levels. So like right over here, this is all dry air. Let me see how the stream can see that. Yep, that's all dry air right there. And if you notice on lands, there's a bunch of dry air. It's very hot. It's no rainfall right now. And what was happening earlier is that, let me pause it on the frame. Right over there, yeah. So as the circulation pulls in the moist air this direction, it also pulls in the dry air over here. So as you can see, it's dry air intrusion, basically trying to poke through the system, make it very dry. Thankfully for the system, however, because it was all thunderstorm activity everywhere, it's basically when thunderstorms are most prevalent that it started developing a bands there that would fight off the dry air. So you can see it's basically the dry air is a lot smaller than where it is right now. It's a lot, basically it completely kicked out the dry air. There is still some dry air over the system, basically. Hard to tell here. But yeah, that's what's trying to stop these vertical heat towers from developing so much. Oh my bad. Look at what this shows. Alright, yeah, but they are definitely quite strong, as you can see in this imagery. Right there, yeah. This is going to, earlier here, this is what happened. You can see all the convection's waning. It's warming up. And then these new things just formed and then started circling around the center. We got 4 heat towers there. Now this one, this blow-up of convection needs to start wrapping around, and it will likely do a good job of that. Fill in the center with more moist cloud tops. But yeah, it's getting very close to landfall, so hopefully after this occurs, it will start fizzling out, meaning less thunderstorms, less intense rainfall. That's what we're hoping on with this. Alright, let's take a look at other things as well. I have model runs as well here. So there is the possibility as well for, I showed you all this system right over here. This system right here could try and develop as it goes eastwards. There's another system in the Timer Sea, near the Ashore and Courier Islands. Right in this area, there's a big blow-up of thunderstorms. And as this system moves over this direction, it should develop some sort of low. And due to this land is almost treated as water for the system, so it could generally develop as it moves that way. And as it reaches the Gulf of Carpentaria, there's free reign to develop in this area. So yeah, I wouldn't be surprised if that does gain some, develop quickly. I'll show you all model runs on that. There we go. GFS overdoes this system, but underdoes that system, I believe. Euro, I think, is a good balance between it. You can see there it is right there, starting to develop in the Timer Sea. Goes over land, starts developing that low, and then when it reaches the Gulf of Carpentaria, it starts really quickly developing. Could quickly intensify to like a tropical storm. Let me see how strong those winds are. Yeah. Typically something we see. It just develops quickly, and maybe the brown ocean effect could make it last long as it moves this way. Or we just don't know yet. Alright. So back to Filipo. Refresh this. Let me zoom out of that area. Let's go back over to the simulated reflectivity on what could happen in terms of radar precipitation. This shows roughly what it's like right now. Um, Basically, more vertical heat towers trying to form around the center, kind of make it an eye, basically. This is circulating around here. There's a really nice band that they believe is going to last for a while. Likely heavy rainfall rates starting to approach the coastline. And then the eye makes landfall at around in around the next hour and a half, it believes. I don't know how correct that is. Yeah, definitely heavy rainfall rates for most of the area. Now I'm going to use this to show you kind of a land-based perspective on it. This is roughly right now this is the scale for rain, basically. The reds are the heaviest amounts, which is like flash flooding potential. Green is just rain there. The more darker the green, the more likely there is for flash flooding. And now let's play this through. Locate your city right now and look at the time. This time is Eastern time. So your time is around, alright, Central African time. So your time is around, let's see, sorry, 8, 9, 10, 11, 12, 13. Okay, so your time is around 6 hours ahead of this. So add on 6 hours to this, basically. Alright, so this is 9 o'clock. So for you all, this is around 3 o'clock, 3 a.m. Then we go to 4 a.m., 5 a.m. Then this time is around 7 a.m. for you all. And remember, locate your city on this map. Try and see where you are and what you're getting right now. This is 8 a.m. roughly, 9 a.m., 10 a.m., 11 a.m., oops. And then this is around noon right here. So you can see in Hambane getting in some of the heaviest rain, Zai, a lot of these cities, Zavala, the capital city as well, getting in on it. This is around, this is 12 hours from now, right here. This is 13 hours from now. So this is, let's see, so, right, noon, 1 p.m., 2 p.m., 3 p.m., 4 p.m., right around here, 5 p.m., 6 p.m. So this is around 24 hours from now, right here. So also keep in mind how long you're in this right here during this 24 hours. Are you in the red a lot, like in Hambane? The more time you're in the red, the more likely you're getting the flash flooding. So then it starts fizzling out away, and then at this point it is 24 hours right here. This point right here. So Maputo could be getting in on some of the heavier rainfall rates. It all depends on where the center of the storm is, of course. Alright, this is a... Alright. So Elite does not show what it looks like here. Alright. So remember, if you have any questions, be sure to let me know down there. But yeah, let's see if we got a new frame of the vertical heat towers there. Yes, right there. There it goes. You can see the new convection trying to blow up around the center there. It is currently over the center, I believe. Well, let me take a look on visible, or shortwave IR. Okay, it's hard to tell in the latest frames. But right there, it starts forming this little edge right there. So let me take a look at real Earth, see if we get a new frame. Alright, for whatever reason this is showing this. Pixel volume exceeded, okay. Let me refresh the page. Get another look at the imagery, see if this shows it. Alright, so it's, what's this, flood detection. Let me see what this is. Okay, so this shows roughly like river flooding and what it could be like within the next 24 hours, just some rise in the water. So if you're in your yellows and stuff like that, it could be flooded there. Okay, I don't know what the gray means. Okay, this is what's been happening recently. Okay. So this has been March 5th, and then you get more and more rainfall once the lake starts increasing. Alright, let me exit out of that. What about forecast now? Alright, well, let's go to Meteosats, this thing right here, the satellite imagery. Let's see, okay, here we go. This is the latest frame right now that has come out recently. This was around 30 minutes ago. And this should show the vertical heat towers and show roughly where the position was. Okay, never mind. This is out of date right here. This. Never mind. Both of them seem out of date. They're just trying to load. Oh, my bad. I did not mean to zoom out that much. Alright. Let me see what my server's saying about it. Alright. So within the next 22 minutes or so, I'm going to update the graphical outlook for 00Z. Alright. Alright, let me see if there's any other discussion on anything else. Just trying to pull up some new imagery just to try and see if there's any new information I can grab. Let me look on Twitter. What's that, right? Alright, let's see. Um, alright. Opening up a new frame, trying to get a general look at it. Off stream right now. It doesn't seem like many people are talking about it, okay. Alright. And so I don't really. Another question is basically how strong is it right now? I don't know yet. Um, it's because I don't think it's strengthened that much. It may be an 85-mile-an-hour storm, 10 to 5 miles an hour in the last 6 hours. That's definitely a possibility. But yeah, I do think that this system is going to be a cyclone at landfall. Of course, I don't think it's going to weaken. But yeah, this blow up of convection could be helpful for it. It could just not do anything of it. This is probably the one of the largest bursts of convections I've seen so far with the storm right here. Trying to funnel around it. Position wise, it's kind of it looks like it's been moving more south and just stalling. I don't exactly know where to put the position on it. But yeah, it could be. Um, all right, it could be in the center right here, but like the thing is, the path of the storm has been moving very. It's been moving. It's been very wonky recently. It looks like it moved to the east briefly there, but I know that that can't occur. It just like looks like it's done a wobble more to the south, and then I don't know what's gonna happen with it. Its center is definitely somewhere in here, so it's all dependent on where it decides to make its landfall. I don't believe it's right here at the moment, because the wind shear isn't that bad right now. All right. So now let's talk about the impacts that the storm will bring right now. Let's say this is the center. This is model data, so it may not be. There could definitely be over 100, nearly 140 kilometer per hour winds trying to funnel into the coastline. And if you'll notice here, this is how we talk about storm surge. There's water being pushed on land, if you can tell right here. Because of how strong the winds are, they're pushing the water over land. Now, anywhere south of here, like anywhere where you see the wind being pushed on lands, that's where you can get the storm surge. Like in this area over here. Now, areas where you see the wind blowing away from the coastline, it's not really a problem. Like right over here, it's pushing out this way, and that's how you got like in terms of the water vapor imagery of the storm. Let me find it. This frame right over here. That's how you kind of got as well with the water being the moisture of the storm right over here, and then the dry air on the northern side. As you can see, this is how it works. Like it's pushing, or it's pulling dry air this way. It's pushing moist air that way. That's how you got that nice southerly band. There was a lot of dry air and intrusion happening here, and it has since fixed it. Now it's a lot more moist. Definitely could be a little bit stronger than what we were looking at before. I don't think it's that strong though. We'll have to wait for microwave imagery or some sort of pass, a satellite imagery pass that we can kind of tell how strong it is. All right. So yeah, another threat, of course, is going to be the rainfall in this storm. Let me pull it up on here. Yeah, rainfall amounts are definitely going to be pretty high in the landfall sites. I do believe the icon plays this part very well on showing where it's going. Right over here, there's the heaviest amount of rainfall, and then it's going to be moving kind of this direction. The eastern side should be the area with the most rainfall. Since remember, it needs the water. It needs this water to make the to spawn more storms. This area is drier basically, so that's why you don't see all the rain on this side. And the more east the storm goes, like in this area. Keep in mind, it's going to re-strengthen when it goes back over water. The more west it goes, the more likely it's going to weaken a lot more because you're restricting its water there. Um, but the more east you go, if you're on this side, for example, you're going to be a lot stronger when you reemerge because you got some of this moisture on this side that you can use to aid in thunderstorm development, stuff like that. But yeah, it's all going to depend on where the storm moves eventually. It definitely, if it does go this way, it definitely could re-intensify to a cyclone out over here while it's trying to turn frontal. Basically, anywhere in this region could become a Category 1 cyclone, then turn post-tropical. It could even be a Category 1 post-tropical system as it starts merging with a front, just because of how those systems work. But yeah, anyways, there's a main issue on terms of the capital. They're most likely wondering, well, will they get impacts from the storm? And I do like using, I think that the icon model precipitation plays it well right now. This is roughly what it looks like right now in terms of where it's getting the heaviest rainfall. Could be a lot of flash flooding in this area. Now let's play it through in terms of hour. Does this work? No, okay. Alright, so if I go down here, Maputo doesn't really seem like they're getting much rain. Just very cloudy, maybe barely any rainfall. But as we get closer and closer, this is around 24 hours from now, right now. So this is around 2 a.m. Local time there. They could just barely miss out on the heaviest rainfall, possibly. Get maybe an inch of rainfall or 25 millimeters, that'd be very good. But now there's also other models that want them to get the heaviest rainfall, where they could get around 100 millimeters rainfall, or around 4 inches. That's mainly the Euro, though. It mainly just depends on where the center heads. Like this one, they have the center going right and down the line. I believe the icon more because it seems like it's going to be east of where that line hits. As you can see, like right over here-ish. The storm looks like it's going to head this direction. So yeah, I do believe that that's how it should unfold, in my opinion. Definitely the southern side and eastern side should have the heaviest rainfall. I don't know about the western side at this point. It's going to definitely degrade, as you can see. But yeah, if it's over here, for example, it's going to be funneling in all this moisture down here, as you can see. So yeah, basically anywhere along the coastline over here, this area, could receive some flash flooding, basically. Or I believe is somewhat likely. Anywhere there could receive some heavy rainfalls and could possibly get some flash flooding. Oh, jeez, okay. Just checking some other things, seeing if there's any other discussion on the storm. Hold on. Okay, the system could definitely try. The Australian system is another one to watch. I'm seeing people talk about that in my server. Um, let me check something. Alright, nice. Alright, so yeah, it's going to be interesting to see how this plays out later on. I'm going to see if they have a new frame right now. Yes, they do. Look at that, see? More convection around the center. This is a while ago. This is around 15 minutes ago or so. I got a new nice burst of convection over the center. I'd like to see how this plays out. That should fizzle out soon as well. There's also a nice new thunderstorm over here where my cursor is. Let me circle it right there. This area. If you can see. Like as the band starts fizzling out, it should reignite later on. Alright, so now I'm going to start working on the newest outlook. Send this out. Alright. Um, I think I'm going to be streaming for the next 15 minutes, then call it a day. I don't know. I'm wondering if the storm's even going to actually try and make landfall there. It might. Like, to me, it looks like it's going to try and move. And I mean, it sounds absurd, but oh yeah, here's the new vertical heat tower they're forming. Right there. But, like, the center's around right there-ish, in between them all. And it might. I don't know. I honestly don't know. That'd be a very good case scenario, I think, if it moves like. Well, let me see. No, not really, because it's still funneling in more storm surge. The quicker it moves over here, the better, because it will die out quicker. I wish I could just, like make a turn that way or something, just die out or something. And no, like the more time it's over water, the more it will strengthen. So we do need it to move over land quicker. It should have made landfall by now, but it hasn't. So that's kind of concerned. Like, as you can see, this run right here shows it nearly over land at this point. The center should be over land, but it's not. Or almost over land. But no, the center looks like it's around here-ish. Looks like it's around 50 kilometers away from the center. The count, it's like, it's still pretty far from making landfall. If it went directly south, for example, it could miss land entirely if it just wanted to go directly south, maybe hit eventually here. But yeah, it's taking its sweet time. It might even intensify some more. Man, you can see how the convection cloud tops there, the highest amount, like the blacks there, were right along the coastline, right there. And now they've all fizzled out, moved to the east. So I don't even know where the center actually is right now. It's kind of complicated to tell. It's somewhere right there. Because the vertical heat towers, these little bursts of convection there, they form around the center, meaning that the center's right around here. So that'd make more sense, to me at least. But there also, yeah, and then there was also one like right around here, so there's the general movement of it. Looks like it's moving south. So it seemed like it was getting very close to land earlier. I thought it was going to be making landfall in like a couple of hours, but no, it may take like 6 more hours for it to make landfall. Alright, off screen I'm going to be working to make the prediction right now. And I'm going to pull up model runs on this thing so you can see what I'm trying to do. I'm probably going to go 85 miles an hour on this, just because it's still, let me see, 18Z is this point. It's right over here where it's likely a cyclone. So it may be even stronger. Alright, here, let me see what other analysis my analysis team is saying right now. Let me take a look at this stuff. I don't think that they came to their conclusion yet. Nope, but pretty soon. It's definitely a cyclone at this point, so I know it's a category 1. I'm going to make a graphic on that off screen. Got a new worldwide image. Oh, is this a new frame? No. Yeah, that's been there. Oops. So we should get a new cone and stuff like that soon. But yeah, like I said, the system's very close to making landfall, so... Alright, there's that. We're currently on code red for the system. Mainly just that system right now, just because of how things are panning out. Since this wasn't really well anticipated, seeing how quickly the storm could intensify. We knew that since it is in the Mozambique channel, storms typically do intensify quite quickly there. Yeah, this one intensified a lot quicker. Alright. Alright, so what's that other system called right there? Hold on. Nope, jeez, my bad. Alright. This system right over here. 18S, okay. I do think it's almost a cyclone, just gotta wait for it to get better organized. Right, like that. I'm giving that system in the Gulf of Carpentaria the system that will eventually reach their 60% chance of development. I think that's well suited. Right, let's see. That's. Remove that. Alright, sorry. Alright, so there's that. Alright. So now that other system, let me pull that up. Since it is moving quite quickly, 93p, I feel like it definitely could develop. It's just ensembles are really underdoing it. I'm going to take a look at the general consensus for models. I feel like a 50% chance would suffice. I feel like doing a 40 for right now, just because of how uncertain it is. No, Euro supports it, GFS supports it, Canadian model doesn't. Icon model, yeah, I'm gonna go 40% on that system. I think that's fine. Alright, there's that. Alright. There's this right here. That's 93p there. Okay. Oh yeah, now I need to do the chances of formation within the next however many hours. Here, 100. Oops. Alright, let's see. That Australian system has the second highest chance, I believe. Here, okay. Australian system within the next 48 hours shouldn't really develop. I'm putting it as a 10 probably. 10, but then a 60% chance. 92p doesn't seem like it's going to develop anymore. 93p, however, I'm going to give it a 20% chance within the next 48 hours and a 60 within the next, or 40 within, never mind. I'm going to do a 10 within the next 24 hours. So that's, or 48, sorry. 48 hours, right? That. Then 92p is going to be a 0-0 chance. Alright. Alright, now let me change everything to code red. Just trying to change the color of everything. Alright, this is our next cyclone. Let me add that in. No, dang it, okay. Sorry, I'm doing this off screen right now, just trying to make the graphic. Make that red. Now today's March 12th, I believe, yep. There we go, I'm going to add this on screen. Oh shoot, hold on, not yet. Let me fix that. Forgot to label something differently. Alright, I'm going to send this in. Alright, there we go. Now I can show it on screen. Here we go. Am I still streaming? Shoot, my bad. My bad. How long have I been stuck on that screen? Oh no, I just did it recently then. It couldn't have been that long. Shoot, okay, I was streaming that whole thing, my bad. Guess I was showing it. Alright. So there's 3 systems around Australia right now. I'm going to share... Okay, yeah, so this is what the screen looks like right now in terms of chances of formation, stuff like that. We of course got Filipo, which is going to go out to sea, eventually leaving the area. We got 18S, which is going to head towards Australia. Definitely do believe it's going to form. This other area of interest is going to try and move towards the Gulf of Carpentaria. There's this other system in the Gulf of Carpentaria leaving. We got 92p with no chance. So as you can see, we got a whole chain, conga line of storms there. But yeah, Filipo is the main threat right now of the stream. We may be doing a stream on 18S if it does become a cyclone and heads towards land. So right now I'm going to post that onto Twitter and other things. Let me see what my analysis team is going with other things. Alright, let me post this out. Alright. Shoot, okay, wrong thing. Let me copy the image. There we go. So right now I'm doing this stuff off screen, posting it to Facebook and Twitter. Filipo intensifies to a cyclone near Mozambique. Then 18S, still not ATC, but we'll head towards Western Australia. We do 3, 4, 93P, and another system could form around. And 5, 92P no longer has a chance of formation. There we go. Cyclone Filipo. There we go. Okay, now I'm going to tweet this, or I'm going to post this on Facebook, so give me all a moment. Alright, Facebook. I'm going to copy and paste what I posted on Twitter.
Yeah, Chase.
Yo, Riley, what's up?
What's up? Sorry, I called the wrong call. That was my bad.
Alright.
All right. Anyway, so what's going on?
Alright, so right now I'm posting an outlook on Filipo intensifies to a cyclone, basically just
Okay,
the...
you want to know something?
What?
It reminds me of Humberto 2007
How so?
in Atlantic.
How so?
Well, both of the storms' evolution can be considered similar. Number one is that both are attempting to rapidly intensify beyond what was seen a day ago when it's about to hit land. And basically, it just really got going since formation. Humberto, for a while, he struggled pretty decently. And it wasn't until right before it hit land, about 24, 36 hours before, that it actually developed. And now that's what we're having here with Filipo. It's starting to develop.
What year was Humberto?
2007 Atlantic.
Humberto,
Yeah.
2007. Oh, whoa.
Yep. And as we see, after the development here of Filipo,
That was real quick. Whoa.
the system, yeah. See, you see what I mean now? Like
Yeah.
it develops near land, and then it gets going, and the eye earlier on microwave looked similar to the radar of Humberto.
Oh, yeah.
And so did the IR structure. So it's pretty interesting how this can happen. I always felt that the environment was there. It was just the window.
I remember you said that storms in the Mozambique channel can intensify very quickly.
Remember, I did say it should be at least a Cat 1?
Yeah.
And then it looked like that I would actually be wrong, and now it's looking like it.
It got another chance, basically.
Well, I knew that it would have its shot eventually. Like, it would have a window. It's just how long of a window would it have? And the window that it's going to have is unfortunate because, you see, it's going to hit land and go over land just long enough to bring it down, and then it's going to be over water and re-strengthen.
We were talking about the possibility of it re-intensifying to a cyclone after it leaves the...
It should, because it's going to have a strong drop interaction.
All of these ensembles show it intensifying to a cyclone.
Well, here. By the end of that run, it's probably post-tropical.
Oh,
but in that area right there,
in this area right here, the earlier parts,
in that area right there, you can expect a fully tropical C1, I believe.
Yeah,
because it will be intensifying under a trough interaction, And you see, here's the thing that even though it'll go over land, it'll lose a lot of steam. It'll go from it's most likely going to be a Cat 1 landfall here in about 6 hours, and it's going to be brought down to a tropical storm. Probably going to, say it's going to come off at 45 knots, somewhere around there, maybe. Okay, and then it will begin to re-intensify. What you have to realize is this time is actually going to be easier to buy because 5 is totally ripping it to shreds. Now, when you have something that's like a Cat 1, Cat 2, that's just starting to really get going, and it goes over land, it does knock it down, but you got to realize it's going to be easier for it this time because the circulation's there, the low-level stuff, all that's there. It's just got to just redevelop convection, and then the normal processes play out as long as it's able to do so, which the environment will support that. So I agree that we will likely be looking at a C1 after it goes back in the channel.
Yeah. All right. So you said you think it's going to make landfall in around 6 hours?
Somewhere around there. 6 to 9.
Oh, wow. Okay. Thought it was going to be making landfall very soon. The forecast cone has it almost making landfall at this time.
Well, that was based off the last forecast, so now it's probably 3 hours.
Yeah.
So, yeah. So, in about 3 to 4 hours, I would expect the landfall to officially occur.
Because I was expecting it to occur by now.
The interesting part of the GTWC forecast cone, and I don't really believe this here, but let's pull it up for a second. Pull up the actual version on the real website.
Right. Let me find it.
Or you can do that too. That works just as good.
Yep.
Is that they think that it's going to start to re-strengthen before it even goes back over the channel.
Oh, yeah, I do believe that's a possibility.
Well, I mean, that would be pretty interesting, but I will say this.
I don't think 10 knots, though. I think,
No. I think more so it'll stop weakening.
Yeah.
But I think once it gets over water itself, it should get going. Like, if it came off at 45 knots there.
I believe what they were saying, though, is because their forecast has the wind field being over land there at that point. So that means that that's like a minimal tropical storm.
Yeah, but the 45 knot point is over water by like 3 miles. I mean,
yeah,
that's not gaining 10 knots just because it's deep water.
Yeah, but what I was talking about, like, as a storm moves over here, it's water wind, like.
Oh yeah, and another thing too that we gotta watch for is if it doesn't go quite as inland as expected, like if it goes more like towards the coast.
Yeah.
Right. It would not lose as much steam because, number one, it wouldn't spend as much time over water. And number two, it would be near the water. And the core, sometimes parts of the core, if it's near water, can suck in a little bit of moisture and heat that can help sort of slow down the weakening a little bit. So that's something that we need to watch for. And not only that, but this is a 3-way advantage for it. Because then when it did get over water, which it would go over sooner and start intensifying sooner, it would stay over warmer waters for longer. So if it goes on the northern edge, the eastern and northern edge of those ensembles, then you could get 90 knots or something under drop interaction. But if not, and it goes,
is that some of the ensembles show it being around 70, 80 knots? And at least in the extratropical.
Well, before it turns extratropical, I definitely believe that it should be a C1. You should get it. You should get to a C1 before it turns extratropical.
Do you think it would be a Cat 2 extratropical?
Probably not, because if it does reach Cat 2, which is possible if it goes on the eastern side, like I said, and goes on the northern edge of the ensemble after it emerges, it would most likely start to weaken when the transition began.
All right.
And let's say if it went to 90 knots, you would probably see it get brought down to 75, 80 knots by the time it's fully transitioned.
All right.
Maybe a little less. Really, man, listen, in order to get a Cat 2 or higher extratropical, you almost have to start the transition at a major.
Yeah, yeah.
and I would even say a 4.
I was just
Yeah.
thinking though that with the baroclinic forcing or whatever, the as it's turning extratropical, it strengthens some.
Well, if we look at the current satellite imagery of Filippo, we can see that it continues to sprout. There is a deep convective burst near the center,
Yeah.
over the center, which will, as you see those rotating around, you're seeing it form an inner core, and
The vertical
that's
heat
gonna,
towers, right?
yeah, and
Seen on.
that will allow it to continue to organize and deepen. And as that occurs, we can expect that the intensity could pick up a bit,
Mm-hmm.
and the rain bands now are on the coast. They're starting to get hit with the rain
Yeah, right here.
and the winds. Right now, the winds might be starting to reach tropical storm force on the coastline, especially since they're starting to peek into some of that deeper convection that's been
Yeah.
developing there with the core. So the conditions in Mozambique are going to continue to deteriorate as the storm intensifies as it moves in. So, if there's anybody out there that's in Mozambique in the area that is watching it, it's important that you have all the preparations completed, that you are ready for the storm, that you understand that there's a possibility, if not a
Mm-hmm.
likelihood, that you will have the intensity going to hurricane before landfall.
Yeah.
The
Crazy
flooding
says with the category 2, there pretty much needs to be some sort of phasing interaction too.
pretty much, yeah.
What does that mean?
Okay, what he means is that, like, you remember, trying to think of what it was, not Lee, but what was that one in 2022? Oh, it was Fiona.
Fiona?
You remember Fiona, right?
Yes.
You remember how it was hauling ass when it was going towards Nova Scotia, and the
Yeah.
extratropical transition was very rapid?
Mm-hmm.
Okay. Well, basically, what happened is that the trough was dominant over the storm. Usually, or no, the other way around. The storm was dominant over the trough.
All right.
Usually, the trough is dominant over the storm, and eventually it succumbs. Well, it still did, but the difference is that it absorbs all the energy of the trough, and
Okay.
it's just essentially it's just expanding so much that essentially the storm Fiona, there was a point where it was undergoing the extratropical transition so rapidly that it
Mm-hmm.
was deepening off of the extratropical forces while still being tropical in nature,
Okay.
because it was happening so forcefully
Yeah.
that it happened so quickly. That's another reason why the pressures were so low in Nova Scotia with that
Mm-hmm.
system. Is
That makes
because,
sense.
yeah. So basically, that's what he means when he says that.
All right.
Which, and that's a smart comment right there. That's pretty much what that means.
Mm-hmm. All right. So, where do you think the center of the storm is right now? Because it's been hard to try and tell.
Let me take a look and see if I can see.
All right. Is it to me? It doesn't seem like it's in the cone of uncertainty.
It is. I think it is, but it's a little more. It might be a little more south than expected, but
Right here, maybe.
um, wait a minute. Where?
Right here.
Go to the tropical tidbits IR. You'll see
Right.
it better.
Let me see. Yeah.
Go to the regular. Yeah. Now
I
play
believe the center's roughly in here, right? Because of the vertical heat towers.
That's correct. That's how I located it, and then I played the loop, and I just tracked it with its expected motion
Right
from
there.
there. So the center is somewhere likely in that location.
So the
May-
west
give or-
of this little island. Let me see where that is.
Yes, more towards the east. You mean more
Or
towards the center,
west, east,
but
or
on the
east. Yeah.
western edge of the blob. And we could be a couple miles off with that estimate, because you have to realize that this is still a maturing and a developing storm. So there's a possibility that the mid and upper levels that you see on satellite with the heat towers
Mm-hmm.
are not 100% coupled and aligned with the lower levels.
Okay.
So there's always that possibility. And if our positioning estimate's off, that would be why.
All
So
right.
that's something to keep in mind.
But
But
notice
based
the
on what
fact that
we know,
this right here is towards the east of this little island right there. If I keep playing through,
it's
it's still to the east of that island, which would be if this little island right here, it's to the east of it, meaning it's somewhere in this area. It's not even in the cone. It's somewhere to the east of that line.
yeah.
So I doubt it's in the cone of insurgency. You said that it could be lower levels, could be in
The
its.
lower
It could
levels
be.
could be, but right now the upper levels and middle levels
Hmm.
are like I said. That's how I located those.
But yeah, it's definitely not in here,
If
right? Right there.
no, if it were to be off, I am kind of thinking that it would be slightly. The lower level would be slightly southwest of mid-level center. If I
All right.
had to guess, then again, it can go either way by a couple miles. But if I had to guess, that's what it is. This timing is important here because number one is that the landfall, right?
Yeah.
So the time of when landfall will occur is going to be in the next 3 hours.
All
Okay,
right.
we can say that. But the timing of it is important because as you see the coastline there.
Yeah, the coastline right here.
Yep, is the coastline. I'm not sure about the tides and when it's high and all that, but the reason that the timing is important in this scenario is because number one, we're dealing with a strengthening system.
Yeah.
So more timing likely means a little bit stronger when it hits.
It's not like it's
But
undergoing an eyewall replacement cycle or anything. It's just
right, it's
strengthening more
right.
time.
I mean, it's not like it's totally. Oh my God! Either. I mean, it's just a steadily decent strengthening.
Yeah.
So, but I'm expecting that it will continue until the landfall does occur. And when it does occur, as I was saying in regards to the timing, I'm not really sure, but I think it's going to be nighttime there, and
Yeah.
it's going to
Well,
be early in the morning. And
right now it's nearly 2:30 a.m. for them. They're
yeah,
six
so it's going
hours
to
in
be making
advance.
It's going to be making landfall at like 5 o'clock in the morning, or 4 o'clock in the 4:30, 5 o'clock in the morning,
Yeah.
something like that. And people, okay, they went to bed and they seen a storm that's just getting named.
I said
And
when
there's
they
a
went to sleep would be around, I don't know, maybe around
probably
here-ish. So this is around 6 p.m. right here for them.
yeah. So well, they probably wouldn't be asleep, but the point is that they're gonna wake up and be dealing with a landfall, probably even woken up by the landfall
Yeah.
of what is going to be either a hurricane or literally right on the border of. So
Mm-hmm.
they had time to prepare based on the models and stuff, but they didn't have enough time
Yep,
to
definitely.
prepare based on the organization level
Because
of
this
the
was a day
storm.
ago right here. This is what it looked like.
Oh, let me say this though. At that point, I
Mm-hmm.
knew that it would organize decently.
Yeah.
But I did, it's this morning when I seen it, it underwent a dry air intrusion or something, and it's starting to bounce back again. But
Yeah.
this morning when I seen it, I'm thinking, oh, dude, this is not good. It had a low level high and stuff. Like I'm thinking this thing could really just go. Like
Yeah,
it
I
could be a
heard on
hurricane.
my
It could be a
I
hurricane
looked at
now
my
and not
Twitter
even showing.
notifications and I hear someone said, "Oh, ATCF says it's 70 miles an hour." I'm like, "What?" So I quickly go look at it and I'm like, "Wow, it's likely
Yeah,
stronger than that."
there was a point that it could have been a hurricane just not showing. And it was to a point where I'm like, wow, this is about to show we could get a bad situation. But I mean, you see the thing here that you got to realize is that in this country of Mozambique,
Hmm.
the floods is what does the damage.
Yeah.
As always, it's the water. And
Yep.
the floods here is worse than usual because the region is usually poor.
Yeah.
They're
Yeah.
usually not well prepared. The government does not help them with the preparation for storms.
Mhm.
As the floods occur, you have people that, like I said, are not prepared, and you can have mudslides and not really so much by the coast because it's pretty flat and swampy in that area,
Yeah.
but in further inland areas because these outer bands they hold a lot of rain and energy and stuff as well.
Yep.
So this is pretty big rainfall event for them. I mean, it's not anything unusual. They're not a stranger to storms. They're usually hit with, on average, 1 or 2 storms a year, with at least every 2 years by one hurricane. So they're
Yeah.
not really that stranger to them, but they still cause a lot of flooding issues.
Yes.
You know,
They don't even have a radar there, so it's a bad country when you
yeah,
can tell that as well.
that's unfortunate. Meanwhile, in the Australian region, there's another one developing.
Yep. This one right here.
Mm-hmm.
I don't believe this is a tropical cyclone yet. I feel like it will be within the next 12 hours, maybe, or 18, 24.
Yeah, I agree. It's just too disorganized.
Yeah. I've seen storms like this, I swear. Like where the center doesn't
Oh
have
my
any convection.
gosh! Look at the GFS
Oh yeah.
for that storm.
Here, I'll show you the model run on here in terms of satellite as well. On
Let me say this: I have learned over the years.
here it is right there. You can see the
I
satellite.
have learned after Islam, I wouldn't doubt it. And I have learned over the years, King,
Yeah.
that I've been doing this for almost 7 years now.
Hmm.
What I've learned is that models are to be questioned but not doubted.
Yeah.
And there's times where you can just throw a model out, like when it had Irma at 892 millibars in New York
Yeah.
City. Yeah, you can throw a model run like that. You can doubt that. But something that is realistically possible, it is to be questioned and not doubted.
Yes. Yeah.
Like, I will give you an example. Okay.
Mhm.
Michael, a few years ago, Hurricane Michael. A few years ago, 5 years ago. Geez, it's been so long. Um, we're watching it develop, and at first the models aren't too happy. The models, they don't really think it's going to do too much. Hurricane week week cat 1, something like that. Then as it develops, the models, they start, every run is just upticking, upticking, upticking,
Oh yeah.
intensifying at the coast. And I'm like, these models are doing this. They are really strengthening it at the coast. And I'm like, what's going on here? What is this?
Yeah.
And come to find out is that it was hitting onto a trough interaction that we didn't see in forecast at the time.
Okay.
So models are to be questioned but not doubted. Another thing that makes me
Hmm.
not doubt a model, you wasn't tracking then, but Wu Tip 2019, it was a Cat 5 in February, and this is something I'll never forget. You can even say it had 2 Cat 5 peaks. Officially, it does. And I think the second one was 150 to 155 knots. And you see, I'm looking at model runs at GFS. It's bringing this thing down in the 930 southwest of Guam, and I'm thinking, yeah, if this was like August, September, October, November, even December, I'd believe this. But that's not how February. And then it actually, you're right, it didn't, because it went lower. It went to like 910. It's like models, I'm telling you, man, models sometimes can sniff something out that no other models see or stuff. Models are
Yeah.
to be questioned but not doubted. There's times when you can be like, yeah, that's not going to happen. But in the end, always remember, models are to be questioned but never doubted.
Yes. Yeah. So it said this could definitely be possible if it's.
It could be possible. It's
Mhm.
known to have strong jet and trough interactions in that region, and
Like
the
last
water,
model run as well,
the
they had the
wa-
same thing.
and the waters there are just a powder keg waiting to be given
Hmm.
its chance.
But it needs
And
to go like that specific path, right? Where it needs to go along the.
well, well, yes and no. It all depends how it develops before it
Yeah.
gets near land and everything. But okay, this system that you're looking at, it will be a hurricane, but how strong of one remains to be seen. Does
Yeah.
it hit off the area or does it curve out? That remains to be seen. There's a lot of here in the ridging and blocking pattern and trough, and a lot of things going on where this can go different ways. And you want to know something?
Yeah.
The development that is on the other side of Australia, on the Queensland side, on the
Hmm.
South Pacific side, it actually has a factor in this system and its track.
How
Listen
so?
to me now, okay? Because when a system, a tropical cyclone, or at least one that's decently developed, exists, you got to realize it's changing the orientation of ridges,
Oh yeah.
of
Yeah.
troughs, the positioning of other low pressure
Hmm.
systems, stuff like that. And in turn, that can affect other systems that are. I mean, now if you got a storm in the North Indian and you got a storm in the East Pacific, yeah, it's not going to affect it. But
Yeah.
when you have a storm that's not really, I mean, they're what, a couple hundred miles apart, so it can affect the orientation of ridges and
We're
troughs.
talking about this right here, this system.
That system there,
Yeah.
yep. So that can affect, and
This
maybe
system.
even the one that's further out, that's very very weak in that
Yeah.
run. But that's too weak, really. So it's more so the one that's in the Gulf of Carpentaria.
Hmm.
But it's something, like I said, something to keep in mind is that it can affect the position of ridges and troughs and things like that affect the steering. So you got to keep an eye on that. The steering current could be weak as well. There's a lot of spread in the models once it gets outside of about 5 days or so.
Yeah.
So it's something that you got to keep an eye on with that. It will be a hurricane no matter where it goes.
I
How
feel like the
strong it
Joint
gets.
Typhoon Warning Center did a good job on the cone for it.
I feel like it's okay. I like their track better than I
Hmm.
do. Like I said, there's a lot of uncertainty because of what I said, where other systems could develop and therefore
Yeah.
it could. So
I
I
also
like
believe
their
it's going to
track.
slowly intensify for the first like day or and a half.
Yep. And then once it gets to about where they show 50 knots, that's where it's going to say "fuck you" to the forecast, and it's
Yeah.
going to be like, "All right, it's time for me to go," and it's going to become at least hurricane. It could become a major. It depends, like I said, on several factors. Where it goes being one of those. If it takes the HWRF route, of course, HWRF makes every storm that has moderately favorable conditions strong, but it could be right.
Hmm.
If it takes the HWRF route, the trough interaction or the jet interaction will be stronger. The system will be over warmer waters prior to landfall. That's why it gets strong. It seems weird that the run that takes it towards landfall makes it stronger, but that's why in this case.
Let's take a look at it. Yeah. Don't see the land at all in this.
Because the truth be told is this:
Hmm.
you want to notice something?
What?
If you've noticed from over the years of tracking, what is one common denominator amongst every intensifying storm that is under a trough or jet interaction? What is the only common denominator?
I do not know. Good conditions.
Well, yes, obviously. But the common denominator is that they are all moving in the direction of poleward and eastwards.
All right.
The reason that is because the interaction is maximized because of the
Yeah,
positioning
the
and relative
troughs
to
and
the
where the
trough of
jets
the
move to
jet.
the east. Yeah.
Exactly, and it's able to evacuate the air
Mm-hmm.
more rapidly, and it's able to breathe. It's able to breathe. It's like taking a big V8 engine and putting an exhaust on it. It's able to breathe freely, and you will see more power as a result. And a storm is the same way. You will see it do more as a result.
Mm-hmm. And yeah, that is the direction the storm is moving. So,
So that's something to keep an eye on with that one as well.
and also Filippo's doing that same movement. Or
And
will
when
do.
does it
Will
intensify?
do. Yeah.
Moving poleward and eastward.
Mm-hmm.
I mean, storms obviously can intensify, moving west and south and north in any direction they're going. But when it comes to trough and jet interactions, the strongest ones and the ones that take advantage the most are always moving in that direction. You notice
Yeah.
that?
Yes.
And there's a reason for that.
What
That's
about Wrong
because
Way Lenny? Remember that storm, 1999?
I don't remember it
Okay.
because
Okay.
I was about a year old, but I know of it.
Yeah.
Yeah.
I'm just talking about like the northeastern movement. Was that as well a jet interaction?
It was trough more
Trough,
than
yeah.
jet, but the jet allowed the trough to swing down there that carried Lenny to the east. So,
Mm-hmm.
I mean, in a way, yeah, the jet's responsible for it, but I don't think that one directly interacted with the jet itself. It might have. I don't know. I have not really looked at it enough, but I know it definitely had to have some sort of trough interaction because I remember seeing a picture of it, and the outflow is like all to the north, and the eye is cloudy as shit, but it's got super deep convection, looking like a normal strong trough interaction,
Mm-hmm.
and then it just dies all of a sudden, like it gets to the point where it's sheared it. So I definitely think, oh, there's no doubt about it that that's some sort of strong trough interaction. But at that point, it's already starting to be sheared. Do you see those like those pointy type of clouds like those
This right, hold on. Oh, hold on.
like the one that looks like outflow fanning out?
This right.
Yes,
See
that
where
is
my mouse is.
outflow, but that's outflow, but it's a sign of sheared outflow.
This.
That's outflow, but it's sheared outflow. So Lenny was being sheared by then, but they usually peak when they're being sheared because when a storm starts to get sheared, the shear doesn't immediately like, oh my god, it's no shear to 40 knots. Shear
Yeah.
gradually ramps up, and there's a point, and it does it faster in tropical interactions, but it still takes a few hours before it gets to a point where it's weakening all the time
Mm-hmm.
instead of strengthening.
Wasn't there like another storm that took its path, Hurricane Omar or something? Yeah. What about this storm?
Now that's even more of a trough and jet right there.
Mm-hmm.
That looks like more of a jet than a trough, honestly. Was it moving? How fast was it moving?
Here.
Yeah, that's the jet.
All right.
I'm pretty sure that's a jet.
That makes sense because I can't really think of an example of it moving a different direction other than
Go to that
forward
loop.
and
Go to that loop. Go to that
Oh,
loop.
this one here.
Dude, look at how
Yeah, I
fucking
can see it.
fast the air's being evacuated.
Yeah.
That's definitely a jet. You can literally see the
Yeah.
jet on the satellite.
Moving
You see,
right
you
over.
see it. You see the.
Yes.
You see the jet.
Let me draw it. Oh, this way.
Yes, but you can see like the jet dipping down to.
Oh, right down here. I see it right here.
No, that's just moisture falling
Oh, okay. So,
a little bit there above the DR and stuff, but you can still see it, like, and how much power it's providing.
yeah. And that is crazy. The loop there. Does Lenny have it? Let me pull up Hurricane Lenny. I know that Lenny was older, so. Oh, they don't really have a picture of it. Alright. Or a loop of it. Wow, yeah. Alright. Let's see in the latest frames. Is that a new one trying to form? Vertical heat tower right over there?
Do you know why they would tend to move? Yes, it is. Do you know why they would tend to move east instead of west
Why?
at that time of the year? Because that's the point of the year where the primary ITCZ, Intertropical Convergence Zone,
Mm-hmm.
has shifted further south,
Okay.
maybe even into the south hemisphere, and therefore the trade winds are gone, and whatever's steering it's free for all, and usually it's influenced
Okay.
by the jet, which is moving in that direction at that time of the year because it's starting to enter the winter, so it's starting to dip lower.
Yeah. Let me see the time of these. And this one was late October. This one was in late November.
Yeah. And then you may ask, well, what about Eta and Iota? Well, that year the monsoon trough or ITCZ, it wanted to stay around for a little bit longer, I guess.
Yeah.
So
Alright, let's take a look at this. So yeah, I can see the dry air intrusion like right through here earlier. Right
yeah,
for Filippo. And then I guess it healed, right? It fixed it up.
it's starting to now. If that didn't happen, though, we would be looking at a well-developed eye right now.
Yeah. I see that there's like a little bits of dry areas like there and there, right?
Yeah, the condition ain't perfect. It's just favorable enough for there to be intensification. Give me a minute, Chase. I'll be right back. I'm going to grab a drink.
Alright, nice. So yeah, the storm is continuing to seem like it's intensifying. We got another vertical heat tower right as this was starting to fizzle out. We already got another one, so wondering to see how good this develops. So right now I'm eating a dinner, so that's why I don't know if you can hear me chewing or not. I'm trying to move the mic out of the way whenever I'm eating.
All right, I'm back, Chase.
Alright. Alright, so something else I noticed though is how consistent the models are on this storm, Filippo, on how little spread there is, right? It's pretty certain where it's going, right?
Usually, with jet and trough interactions, there's generally a tighter spread of model just because of the fact that, I mean, it's all being sucked into one location essentially. So there's really nowhere else except for it there or it can go. So that's why you're seeing a little bit more spread. So,
Did
yeah.
Jiangsu undergo one?
The Jiangsu?
Yeah.
What do you mean?
Did it undergo like a trough interaction or something?
Oh, it underwent a strong jet interaction. The Jiangsu, dude, there was a point when the Jiangsu, it was like, I don't know, man. I'm not so sure the Jiangsu can even become a major. Then I woke up and I see 125 knots, and I'm like, I shouldn't be surprised about this. And in reality, I'm not, but I'm still like, damn. The Jongu. The Jongu was no joke.
Oh, Angrik.
It,
Angrik went. It was going southwestward, so
Hendrik was,
just a normal
yeah.
intensifying storm.
Yeah, but it was a big ace machine.
Yeah,
And right now, the South Indian needs another ace machine.
I don't think we're gonna get that right for a while.
We're not, but we can get decent ace out of 18S.
Hmm.
But yeah, it's going to be a below average season in ace unless we get a big ace machine to show up. Unless we get a Freddy. And I think it's too late in the year for that now.
Yeah.
We could always get something in April too, at the end, the last week of March. The season's not over yet, but we're gonna need one storm with like 35 ace, or we're gonna need two with like 20.
Yeah.
That's after these two storms here. And Filipo is probably gonna contribute maybe 5 ace, and the
Yeah.
other storm will contribute like maybe 10.
Hmm. I do notice that there are some more like colder cloud tops developing along this band. We got several here. We got this one that formed, this one, and then this one right here. Those vertical heat towers, they aren't right. They're just bursts of thunderstorms.
Well, I mean, a heat tower is technically a convective burst, but we just say heat tower in a meaning that when you say that, you know the storm's intensifying. You know that it's doing internal work.
Okay.
You know that it's becoming better organized. So I wouldn't really say that in reference to the outer band, but I would just word it. We can see it starting to flare up a little bit.
Mm-hmm. Seems to be having difficulty too. Is this related to D-men? Like diurnal minimum?
Hey, yeah, but it shouldn't be D-men there. It's probably related more than anything just to the fact that there's not really as much instability in the atmosphere as there really needs to be to support core intensifying along with intensifying banding.
Yeah.
And really, I think that's what it is more than anything. The dry air that's in the area, moderate level of mid-level dry air, is contributing to some of that instability not being quite as high as it could be. Because outflow-wise, I mean, and you do see, and you see it a little bit in the water vapor, is you also do have a little bit of shear pushing on the north side. It's not really that strong. It's probably 10 to 15 knots, and it's at the mid levels, but it is capping it a little bit from really going. And same with some of the mid level dry air. But overall, it's an intensifying system, and you can see the outflows expanding even more to the north.
Mm-hmm.
And pretty impressive that if you look over by the island to the north of Madagascar.
Yeah.
Right over there to the left of that.
Right here?
You'll see that, you'll see that the flow of those clouds is coming off its outflow tail.
Yeah, I see it right over, or the outflow right over there. Right?
So that shows you that it's expansive.
Yeah,
And,
the better the outflow, the better it is, or the easier it is to intensify, right?
Depending on all other factors, but usually the outflow is not improving unless other conditions are, except oceanic wise, but upper level wise, and especially shear wise, because
could the outflow form other storms like this?
Usually the outflow will shear other storms from forming.
Okay.
That's a big reason why 2023 WPAC did not have as many storms as it should have, as you usually see. I mean, 17 storms and 278 of like, what the frick? That is an unusual number.
Yeah.
Well, you see, when you have a lot of long-lasting, big systems with a large influence,
Hmm.
it'll prevent storms from forming. It'll almost shear them off. It'll steal the vortice from them. It's hard to get a vortice to form
Hmm.
in
So why are
that
these forming?
scenario. That's just regular thunderstorm flare-ups. If you
Okay.
mean like thunderstorm flare-ups, yeah, it makes it more common. But if
All
you
right. Yeah.
mean like another tropical cyclone forming, then no, it makes
Well,
it less
yeah.
common.
Because this is shear. Yeah. Right. Just a
Well,
bunch of shear.
outflow essentially is shear, so
Hmm.
yeah, I mean it's just shear that works in favor of the storm.
Yeah.
So
Yeah.
essentially, outflow is shear.
Right. How strong do you think this system will get before it makes landfall?
I'm just gonna go with a borderline hurricane, maybe 70 knots or so.
All
I
right.
don't think you'll see an estimate from the JTWC of hurricane unless they do it right now at the advisory that's due out in 8 minutes.
Hmm.
But I believe that in reality, that you may see it. You may see it reach that, and that is the last one they have not yet put out an estimate for is Filipo. They put out an estimate for the others.
Okay.
18S is downgraded to 35 knots.
Do they have a new cone for that storm?
Not yet,
All right. When do they
but they
release the
should.
cones?
Well, the cones, it's the same times as the NHC.
All right.
The ECF and times are the same. The cone times are the same. So you should see one at 11 o'clock today.
All right.
A new cone. Sometimes, and most of the times, the GTWC does it a little bit early. So you could see one maybe in an hour.
Okay.
So yeah.
Oh yeah, I see it right here. 35 knots, 1,000 millibars. 92p, 25 knots. 93p, 15 knots. All right.
Now 93p, I've not looked into it much, but it could form and it could be somewhat not slop,
I don't know
but
what.
still
Yeah.
kind of slop. So
I put out a 40% chance for it.
that's pretty decent.
Yep.
That's pretty fair for now.
I have a 60% chance for the system to the west of it.
What in the Gulf of Carpentaria?
Yeah. So that system right there.
Wait, so the ECM takes it strong, or not strong, but it takes it to a tropical storm. What's the ECM take it to? 988. You want to know what it is with that?
What?
Is that it's the Gulf of Carpentaria is obviously very small.
Yeah, yeah.
It's somewhere that has an absolute unbelievable amount of energy, but it's somewhere that doesn't have very long to take advantage of it. And that thing is monsoonal. And let me tell you, for being a monsoonal, that thing tightens up quickly.
Yeah.
If it had another day, you would see easily major.
Mm-hmm.
Evil.
Here's the icon model on it, because it's already doing the brown ocean effect, trying to organize a center over land. So, I mean, it's already trying to develop before even getting there, and then it's just...
That's the one development, the one advantage, I mean, that it has is that it could develop before it gets over water.
Yeah.
Yeah.
And then we got, alright, the Canadian model as well.
The longer this thing spends over water, the stronger it gets.
This one has it weakening, but...
It hasn't taken a pretty stupid path. It's probably
Yeah.
not going to happen too. And if it did, it still wouldn't weaken that much.
Yeah. So the brown ocean effect also keeps it intact. Like this right here, we'd get like another Lincoln almost out of that.
Yeah, except that maybe this time it doesn't actually go back over water.
Yeah.
Lincoln was a disappointment, man.
I thought that was going to reach cyclone status when it got back out. But I was preparing for a live stream, but no. Just was a remnant low at landfall. I believe.
I'll think it weakened to a TD.
Mm-hmm. What are your thoughts on this new AI model that the Euro made?
I've not used it, so I'm not really too sure.
Okay.
but AI models are becoming more popular.
Hmm. What's an example of one? Like, I think that this is the first one that I've seen on this website.
Um, that one that they've had for a little bit on Easterly Wave, but I don't really know. They're fairly
Okay.
new.
Yeah, I think that they could become a lot more accurate than our normal models. It just takes time. Yeah, this one shows it a lot more south when it's over land. So and it makes landfall almost immediately.
Hmm.
Goes back out over water. So
First of all, it makes everything way too broad.
yeah. Let's see. Where's the Indian Ocean? There we go. There's the. I've been trying to learn a lot more about tropical cyclone transitions and stuff like that, and how they transition with fronts. So this is going to be a really good example, I think.
Yeah, yeah, it is, and it's going to be a pretty good and quick transition. So, I mean, not as rapidly as Fiona, but you still should watch. The South Indian has this a lot. Trough
I
and jet
remember being
interaction.
so excited for Jaungu, but then it just got like obliterated.
Why you
Whatever.
thought it would transition as strong?
Well, no, I mean the system basically just vanished over in the Indian Ocean, or like it
What the
just,
Jongu
yeah, the circulation just decided to die out very quickly.
jet.
Okay.
That's the difference between trough and jet. Trough, it could go on another week as an extra crop.
Yeah.
Jet, it just shears the shit out of it until it's done.
And Greg lasted around a week as an extratropical. Went south of
It
Australia, nearly south of New Zealand.
yeah, that's what I heard too.
So that a trough interaction, or was that just?
Yes, at that point it was, but when it was intensifying, it was more so just regular
All right, yeah.
intensification.
Right, so yeah, models like that can only be used for the synoptic pattern. That's the AI models. Yeah, I feel like it does good on that. It's not really useful for rainfall totals and stuff like that. I wish that this would show the.
Estimating rainfall totals are. I mean, it's good that they have them to know generally what to expect, but
Hmm.
it's like saying that you're going to get this much foot of surge or you're going to have this many mile-an-hour wind. I mean, you don't really know. It could be more, it could be
Yeah.
less.
Is there a website to see possibly how much surge this is? Know that there's a website for extratropical cyclones.
Wait, there is? I didn't even know about that one.
I forgot what it was. Extratropical storm surge. Is this it? I don't know if it's live, like up to date. I
Okay,
remember.
so if you find any maps, what you're probably going to find is it shows you what so and so would cause this amount of inundation above sea level and all this. It's not going to show you for this specific storm.
Hmm.
I know the IMD has something that they use, but that's only on storms they are issuing on.
All
And
right.
when they issue, they underestimate like absolute crazy. So it's basically not able to be used anyways. So essentially, it's kind of hard to really have anything to go by.
Yeah.
I mean, it really is. But I know that historically, storms in this region are bad.
Oh, no, it's not here. Um, website not found. Yeah, I can't find it. I remember that there was this like one page when I was at the TAFB that there was like this free to use website where you can see worldwide storm surge. I forgot the website. What's the name of the one the National Hurricane Center uses?
Slosh.
How do I spell that?
Slosh.
Okay, slosh. Okay.
It stands for something like sea, land, ocean, seawater, something.
See if I can find images of it.
No, just Storm Surge Slosh. You're better off looking up.
All right. Let me search up global. Oh, it's sea, lake, and overland surges from hurricanes.
Well, I was close enough.
Yeah.
I knew it stood for something like that. Do you know what HOWRF stands for?
No.
Hurricane Weather Research and Forecasting.
Okay.
Do you know what ECMWF stands for?
No.
European Center for Medium Range Weather Forecast.
All right. GFS is Global Forecasting System, right?
Yeah.
What does the icon stand for?
I don't know. Really, I think it's just, I really don't even know.
Do you know what AROME stands for? Like, what is the AROME model?
I don't know. It's something new.
Because it's for this specific region.
Oh, yeah. I literally have never heard of it. I really, truly haven't. But if it's for that specific region, it's probably not going to do good with TCs.
Operational at Mateo, France since 2008. Doesn't say what it
so
is.
it's basically their equivalent of the NAM model.
Yeah. Yeah, I think that these kind of models do good on precipitation, stuff like this, in the next 24 hours. Not exact, like for exact locations, like this 12 inches of rain could happen over there, wherever. Just depends on how the thing plays out, of course.
They might do better than global models in this scenario, but I don't think it's going to do better with intensity. It's not going to do good with intensity. It's going to overstrength.
Of course, yeah. Like, here's... Okay, here, let me pull up the rain thunder thing. Says it almost has an eye overlaying there, like that. And I think it does kind of good. Oh wait, no, hold on. My bad. I was on ECMWF. Let me turn back to room. Yeah, there's the system at landfall right there. They have it in 2 hours. Let me see what the other models have it as. Euro wants it in like around 2 hours, 3 hours. GFS. GFS wants it over land right now, so it should. The GFS thinks it should have made landfall already. I feel like Icon is right in this situation. Just where it is right now and where it's headed.
So you want to know why it hasn't made landfall already, and the GFS thinks it was going to? Because the GFS was consistently under strengthening it, and therefore it wasn't feeling the trough interaction that holds it back from going west as fast because it's feeling the effect of another low pressure which attracts it. And the GFS screwed it up, and I knew it was going to. There's sometimes you need to just not pay attention to it, and this was one of them.
So wait, where was it? Here, let me pull it up on here. Where do I see it? The trough there.
You don't really see it on this map because of the fact that there's a ridge there.
Mm-hmm.
But you see what it is that when the storm gets stronger than the model effect, it changes steering around it. It changes stuff that is going on. Like I said, how it reorients different ridges and troughs and stuff. And the reason why it's going west slower now is because of the fact that it is feeling the nearby trough and jet that is located to the south, and the GFS moved it inland too fast. It did for several days, and I'm glad that we are past that.
Yeah.
It's the outflow
Yeah, I
that
see it.
connects it, that does the pull. You see it?
Oh wait, where's the trough in this?
Okay, you see right there below the outflow layer?
Right here?
Right there, a little bit down,
Oh, hold on.
a
Oh,
little
would it
bit
be right
down,
here? This?
not that far south.
All right.
You see where it started, like the yellow is?
Oh yeah, right around here.
A little bit above that, like where the green is, would be like the edge
All right.
of trough.
And this is the jet right here, right?
That's the jet. Yep.
All right.
The purple being the strongest part of the jet, obviously.
Yep. So it is going to have a jet interaction, right?
Yes, but it's interacting more with the trough.
Yeah. Nice. Oh wait, like how do these storms form? You see, like right here, this thing. How do these low pressures form?
There can be cut-off loads that come off land. There can be troughs that attempt to organize into upper level lows.
It's like I'm remembering. It reminds me of Isa, or that storm.
Right. It could be a upper level low that somehow produces convection and make its way to the surface. It's rare, but it can happen.
Mm-hmm.
It could be in that right there.
Convective feedback, right?
It probably is, yeah.
Yeah.
But I mean, those things
look at
can
this
happen.
storm right here.
That's not going to happen.
Yeah.
But things can happen where there's cut-off lows.
Isn't that where Jobo went on one of those years?
What?
Jobo or something?
Yeah, it was probably a hurricane.
Oh no, it was a tropical storm. Here, let me pull it up. Tropical storm Jobo. Okay, 2021. This storm right over here. Oh wow, nice little. I don't think that's an eye.
It's basically the equivalent of Beryl.
All right, it was a hurricane. Okay. Yeah.
It's basically the equivalent of Beryl.
What year, Barrel?
2018.
Okay.
Or Gonzalo 2020.
This system?
Yep.
I see like a little eye in it. Okay, yeah. Oh wow. That's an interesting storm. Nice. All right.
Or Gonzalo 2020.
Yeah, I know that storm. Alright, let's take a look at the newest frames of the loop. See how the vertical heat towers are working. There's no new frame. This is a little bit old. Let me
The new advisory downgrade.
Oh wow. How weak is it now?
It's not any weaker, but they say 55 knots. But I think that you're seeing these heat towers go up, and I would say hopefully we'll get some observations. But man, you just don't get no observations here in Mozambique.
Yeah. Are these things as well? Vertical heat towers, this and that?
Essentially it is, but it's not. The main heat tower, as you can see. So that means
is the center over here then? Roughly.
It could be. That's where the mid-level center could be. Again, the low-level center could be displaced.
So it's because here's all the dots that I've seen for like the center.
Because it hasn't been able to actually sustain a lot of the heat towers.
Mm-hmm.
I would probably expect the low-level center to be a little bit displaced.
Yeah.
It's hard to say, but I would expect
Like
maybe
since
a
that's the
little
path
bit.
I've seen right over here of the towers, roughly, in terms of the mid-level.
And that's the expected motion. So that would align with what we've been seeing
Yeah.
as it's been moving. So I would concur with that statement there. With that being said, we're probably around 2 hours from an official landfall
hmm
here of this system.
Wait, has the Mateo France updated anything?
And I don't believe that. I believe that when
Yes,
it
they
nears land, it'll convectively blow up. Due
Okay,
to
now that
conversion.
Mateo France has it as a cyclone before it transitions, before it's
Okay.
transitioning.
One thing that I don't like the Mateo France that does
hmm
is when a storm goes over land, no matter what the intensity, it's called overland depression.
Oh yeah.
I don't like that. You
hmm
could, so you're saying that okay, if you're gonna have a different category for overland, then whatever, but don't say overland depression if something is a major hurricane over land. Like,
Yeah.
so you remember
What was it? Freddy?
Freddie?
Yes.
Yeah,
We were
you remember
streaming
when
during
it hit?
Freddy. Yeah.
Yeah, you remember when it hit?
Yeah.
It hit as a Cat 2, and they had it at 90 knots both times, and it said overland depression. Like, the wording of that is just weird.
Also, remember when they increased it to a very intense tropical cyclone when it was weakening?
Yeah, I do remember that.
That was so strange. They never had
And
it
there
at
was a
its
point
peak.
where they wanted to evict a landfall in Madagascar.
Oh yeah, yeah,
Remember that?
yeah, yep. We were streaming during that. I remember right as it was coming out.
And I knew it wouldn't happen.
Yeah, I mean it was already weakening, and they didn't even have it as its official Cat 5 or the Cat 5 peak.
Not only was it only weakening, but storms approaching Madagascar are known to be weakening because of the fact that they downslope dry air from the mountains, the
hmm
angle of the coastline, the angle of the storm, the low oceanic heat to downsloping ratio is not favorable.
Yeah. Um.
If you notice something, there's only one place that you generally don't see downsloping. Where is that?
Um. I don't know.
Luzon.
Oh yeah. Okay.
Luzon, because it's got fucking absolute fucking rocket fuel off its coastline to work with, while
Yeah.
Madagascar doesn't have that. It's got good water, but not at depth.
Yeah. Yeah.
Madagascar does not have the oceanic heat content that the Philippine Sea does.
hmm I remember with when they were going to VITC, I think that we were discussing it. It did it because like preparing the people there.
Well, yes, and also covering their asses in case it happens.
Yeah.
So it's probably a combination of two.
Yep.
But it's more so preparing the people.
Right. So that's their position as of hour 4 at La Reunion local time. What time is it there? Local time. It is 5:14 a.m. So this was around an hour ago. Oh. So an hour ago they believe it's right there.
Something I can say is that when you are dealing with these types of systems, you're going to have a lot of people that are, like I said earlier, unprepared, that are not ready for the rainfall. And the rainfall is what the issue is with these systems
Yeah.
that hit these poorer regions. And it's always the water that does the damage. But rainfall is usually more of a factor in areas that are not as developed. The
Yes.
response by the government is not that great. The preparations by the people are not that great. The weather agencies do not do a very good job at estimating and forecasting and informing people and all that stuff.
Mhm.
Well, anyways, here we are with one going to hit. And like I was saying, the main difference here, and compared to this region versus other regions
Mhm.
that get hit with storms, that get rainfall, is that most of the regions that are hit with PCs on average, they get a fair amount of rainfall in their summer. Mozambique doesn't get as much rainfall in the summer as most countries that are hit do. So
Okay.
when they do get it, that rainfall does a little bit more because they're getting a lot of rain at once.
Yeah.
So that's something right there that is a big factor.
Hmm.
And this system, if it would have developed sooner,
Yeah.
we could have a serious situation. So they should be thankful that it's not as bad as it could be, but they should also still take it seriously
Yes. Yeah.
because rainfall is still a threat. There could be some places with over a foot of rain for sure.
Yeah. Yeah. Definitely along the coast as well.
Along the coast, and there could still be places inland. Like for example, there could be places um, in western Mozambique, even there,
Hmm.
that could see rainfall 6 inches maybe over the course of the storm. Because you got to realize, man, these outer bands are decently big, and there's a fair amount of them. They're not really as convectively active as most of the time because of some of that low instability and some of that dry
Hmm.
air that I mentioned. But you still have a lot of banding, and you have a rainfall. It's more one of those constant light to moderate rain deals.
Yeah.
If that goes on for 2 days, you're gonna still end up with at least 6 inches of rainfall, even inland. You know what I'm saying. So,
Yes. Yeah.
but yes, by the coast, by the landfall location, and inland is as usual and always.